problems. And then we'll talk about, well, that really in environment you've already learned there is no single issue. There's never a single problem. There's always, so, and there's neither is there one solution. So there's only the combination of solutions that we can employ to resolve some of the problems or the issues. So there are really no silver bullets, and we'll talk about that too. That would be quick. And then, of course, we'll do a bit of an exercise. All right, first things first, let's talk about the assignments. I know everyone stayed up late last night and skipped the, I can't believe I forgot to watch it because of Olympics, the Tonight Show. But anyway, so how many, who would like to share with us, I guess the assignments, does everyone know what the assignments were? We're supposed to go out and look at digital or print media and news and look around and to see what we can, if we can find some events that relate to what we're going to talk about tonight. More specifically about talking about flooding or impacts of water quality or impact of water quality and rain. Rain, I know right now, actually today I was looking out, I said, what a good day to talk about stormwater. It seems like the first day we have something flowing, so it's great. So anybody would like to share what you had found? Yes, ma'am.
I went out and did the Down and Dirty Easy, and I went to the Duluth flood in 2012.
Excellent one.
I thought I'd see what Noah had put out about it, and I learned a lot of things. A lot of the things we had in our last class were in there. The new previous records, inches of rain per area of time, or for a time ratio. So sometimes it was 6 hours, sometimes it was a day,
Wow.
sometimes it was 1 hour. The amount that was coming down was so much. It was considered a flash flood, which we haven't really talked about yet as to what flash flood is really defined as.
Let's talk about that. Let's remember. If we don't, please remind me. We'll talk about that. Yes.
There were 6 new records: greatest 24-hour precipitation, greatest 2-day precipitation, greatest June 24th, or June 24-hour precipitation, greatest precipitation in the June calendar day, for that day and for the day after. For me, the interesting part of what I printed was actually the verbal conversations about there was a chronologic discussion hour by hour done by, it was a compilation of National Weather Service reports. And so it started talking about other issues like manhole covers getting pushed up and walls collapsing, and then which roads were flooding and how high it was on the cars, and then sidewalks caving in.
So the stress on the infrastructure, on the things we built to handle the flooding. Yeah.
And how they weren't handling it. Submerged cars, sinkholes, the power dam. I hadn't even thought about the power works had to change the amount of flow they had going through the dam. Businesses were affected, power outages, rivers were flowing over the highway. The roads were deteriorating, people were stranded, the piers and docks floated away, the train bed tracks were impacted and the train service stopped. People were stranded in islands surrounded by water. And then they did a look back with that of the flood of 1972, which was very similar, and that discussed things like we had talked about in the previous class about terrain. There's an 800-foot drop in a mile of in a mile of land in Duluth, so that topography makes it really complicated for what's happening with the water. The culverts got pushed out and moved away. The sheer force of the water was probably the thing that I found the most fascinating about this, because as you recall, the zoo animals escaped. That's right. But there was another chart that's similar to the hyetograph that we learned about last time, and it's not exactly the same thing, but it has the same kind of chart, and it's about the water flow that's going down the St. Louis River at that point, and it has a sheer straight up peak, and then it slowly goes down.
Let's remember that because we'll see a number of them tonight. So we'll talk about those graphs more.
And the last piece I did in looking at this was that is in kilo cubic feet per second of amount of flow. It's a phenomenal amount of flow, and when it is at flood level, there are 153. I couldn't do kilo cubic feet. It's per second. It's kind of like impossible to understand. So I went gallons per hour, and that's 40,610 million gallons per hour that were flowing at that point in the river. And it's just a phenomenal amount of water when we think about it. So that's what I did.
Thank you very much. Sounds like you had fun doing this. Good for you.
And just so you know, this isn't amplified in this room, but it does help your questions and answers get on the videotape for people who might miss this class.
I went back to a storm that I was in 1965 when I was living in Denver. They had a massive storm that went along the Front Range for about 5 days, from June 14th to the 20th, 1965. And I worked at a place which was about 100 yards from Cherry Creek, which was just a little trickle of water. Side of it, and I lived on the other side of Cherry Creek, so I wasn't very interested in those kind of events at that time. But I got up to go to work, and I found out that all of the bridges in Denver had been blown out, except for one. It dropped 9 inches of rain in 1 hour on Devil's Head, and the water came down, and debris and stuff hit up against a bridge until it got a 20-foot wall, and then it blew the bridge out. It came down 20-foot high crest and you're watching houses float by and stuff. So it did tremendous damage to Denver. In the industrial area, and it was transportation. Unfortunately, I couldn't get to work that day.
Bummer.
We sat on the highway and drank coffee and talked with each other. Some of the amounts of water flowing were pretty incredible. One creek had 466,000 cubic feet per second. In Lamar, the rainfall was 3 times the 100-year expected rainfall for a 12-hour period. Plum Creek measured 154,000 cubic feet per second before the gauging station was blown out. Now, I've been looking at climate change, and this is what kind of drove me to go back to this and look at this and see if this was a precursor. And so I tried to find out if there was anything that went back very far, and I found some stuff where there are some indications that climate change started in the 40s in the equatorial zone, and in the 60s in the temperate region, like along in Colorado. So it could very well have been one of those stalled out rainstorms that was in one of the wavy loops of the I forget the word. The jet stream.
Okay. Well, thank you very much. What I liked, what I noticed, at least from listening to both of you, and thank you for sharing, was the how you noticed that water has energy. And that's another thing we want to remember, and we'll talk about it more. That, as you said, the physical impact that water can have is very interesting. Anybody else? Maybe one more, please.
I looked up impacted water quality, and I remember reading an article in the New York Times a few months ago
Thank
Impacted water quality. Oh, thanks.
That helps.
Good, that helps. I remember reading an article in the New York Times about 4 months ago about the Gowanus Canal and how their Mayor Bloomberg at the time was going to make a sponge park to allegedly help infiltrate stormwater so it didn't mix with the sewage because they have combined stormwater and sewage in New York City. And I looked it up, and in researching for that, I couldn't find the exact article, but I did find several solutions that they're working on. One is at several of the elementary schools in Brooklyn, they're making green playgrounds, and it's like the whole area is designed to infiltrate water. And there is a sponge park there, and then the other that's in another part of New York. It's in an area that they're kind of gentrifying, so I find it interesting that they're trying to tie this to city gentrification. The other major article I came across was that the city is going to dredge the canal because it's been used for industrial waste since like the early part of the 20th century, or probably even before that. And a lot of residents are against the way that they're going to implement this because they don't know what they're going to do with the sludge. And I have a friend that lives in Brooklyn, so I was asking him about this, and I'd like to read his response. He writes, "I am not familiar with green parks. I'm as cynical as the next guy, and it's hard not to view this as a sop to contractors with contacts in City Hall. Obviously, it's a good idea in principle, but this is an awfully small sponge. Real forests, of course, would be more important in water management, minimizing erosion, etc. The Gowanus neighborhood was always industrial gritty. A lot of the toxic sludge that wound up in the canal was the result of heavy industry, which is mostly now gone from the neighborhood. What has happened is that Gowanus, roughly just east of Park Slope and south of the also rapidly gentrifying Red Hook, has suddenly become cool. Residential construction and conversion of old industrial space is up. This will probably put more ecological pressures on the immediate area that this sponge park can possibly compensate for. I'm not exactly sure how a toxic waste site is cleaned and what level of abatement is considered sufficient in an area that it is at least partly residential. I recall that there was a dredging of the canal several years back. I think it was before the Superfund site designation. It's still quite smelly, but hardly the smelliest in the city. I don't think this is the only Superfund site in the city water either. I seem to remember that Newton Creek, which separates the northern waterfronts of Brooklyn and Queens, has a ton of still leaking petroleum distillate contamination in the ground from abandoned tanks, together with excessive cancer rates. Perhaps ironically, the areas around Newton include hipster Williamsburg and Greenpoint. The other irony is that after the storm Sandy, Red Hook and Gowanus were among the hardest hit areas on the northern waterfront of Brooklyn. We have friends that took over a restaurant, reputedly formerly a mob restaurant, only about a block from the canal. Overflow from the canal got as close as their parking lot, and then he gave me a map of it. So,
wow. Thank you. Wow. Not only did you did the article, you did investigation too, so that's great. Thank you. We couldn't have orchestrated this better, at least for my sake. They were like, I think I got one with me, so thank you. There were a couple of things from your the articles you shared with us. What touched me was the fact, a reminder, the physical force of water, that water has energy. And a couple of things you talked about, they use the analogy of a sponge, using it for wetland, is the idea of using a function, replacing the functions of the things we have lost. And then there was a mention of, well, these are all good, but it would have been much better if we had the original forest, which is Again, we couldn't have orchestrated better because later on we'll talk about it. One of the smartest things we can do is to preserve what we already have, and we don't have to worry about a lot of things. So this was great. The whole purpose of this, as a reminder, we already know it, but this is a good reminder, at least for me, that the water is interesting, of course, because I'm interested in it. It's got to be interesting, but also it's because it's real. It's not just merely an interesting issue. It's an issue that we deal with on a daily basis. It shapes our lives. It has a social cost. It has a physical cost. So it's an important thing. We can relate to it. No matter what you do, you can relate to water. Okay, good. So this is the exciting part. We're going to review what you guys covered last time, but I hear that there were a few people who didn't make it to the class. So we won't put anybody on spot. It was just a quick overview. Diane did this, and she's one of the fantastic engineers in the region, and I'm sure she did a fantastic job on this. I just thought, again, there were a few things very interesting that she covers. I wanted to go over those because, I think this series are set up perfectly in a good schedule because there are some of the things that we need to carry from last time to tonight's discussion, and we'll just quickly go over those. Again, number one is the movement of water. We got to keep remembering this. Water moves. That's really important. We want to know. We got to remember it. The simplest way of remembering is that water moves downhill, right? And it came on the rain. It's going to go down to the ocean, so it's constantly moving. And as it moves, we want to understand how water moves. How does it move downstream, right? I'm sure you guys talked about that. And then we want to remember again, water shapes the land and our lives. And we also they talked about precipitation patterns. And you mentioned climate change. Gosh, you guys have already covered all the topics we're going to talk about. You talked about climate change, impact of we'll call it changing climate on patterns of the rain and how that changes the stream flow and so forth. So it all is connected with each other. So we'll talk about those. So what are we looking at here? Water cycle, right. I was even going to help, but I remember this doesn't show there. So, but it says it's a water cycle, right? It's a good reminder again. It's a constant move, right? It's constantly moving. It's going from the ocean up, sky, down, and so forth. But it's not as simple as it is. It's got many parts, many different things that's happening. So unfortunately, fortunately, we're just going to be focusing on this little bit tonight, right? We're just going to be talking about the surface runoff. We're interested to see what happens when the rains come, hits the ground. How does it move downstream? That's what we're interested in. And then objective 2 was how water moves. Well, we're interested in how water moves on the surface, but in reality, water is everywhere, right? We have groundwater, we have surface water, and in groundwater, water moves somewhat similar to the surface water, but we have aquifers and so forth. Did you all cover this all up? You know all these things we talked about last time? Good. I don't see anybody shaking their heads. No, Okay, and then the idea that water shapes the land. And that is true. Not only shapes it physically, it charts the stream and the lakes and everything, but it also, depending on where the water is, most of the cities are built around the water. So it also has an impact on the social. Okay, that's okay. I'm sure this is a fantastic facility, so everything is new. So good. Now I can blame everything that goes wrong on the computer.
Oh, and you should.
Okay. So we go. That's okay. We'll do it this way. Sorry, folks. Maybe we need to get out. Was it 2 of them?
Not sure. No, try.
For all of you who were excited that this thing was going to end early, it is not. We're going to go on. We're going to do this. Okay. So, and by the way, this is a participatory class, right? So, it is. I'll keep talking unless you ask questions. So you have an incentive to ask questions. So just ask questions. Don't I hope you're not going to wait for this, earth-shattering statement or anything like that. Ask question whenever you. Good question. Good question. So we have water that wants to go infiltrate into the ground, right? And if it hits the surface, maybe it's gravel, maybe it's sand, so it easily can go, let's say it is sand, it can easily penetrate or infiltrate into the ground. It maybe hits some loam, it can still find its way through. But what if there's a rock formation there? What is a packed clay? Like if you're in Plymouth or Maple Grove area, you have this what they call yellow clay or bluish clay that nothing moves through. It's so packed tight that you can pour water on it, and it will take a long time. Water will just simply will not go through it. Or if it's a rock. So that becomes your confining bed. It confines the movement of the water. Good question.
And then it's seeping through those lines, or like seeping.
Right. Nowadays everybody's just talking about fractures and so forth. So no, you may have fractures that will find its way through and there are parts of Minnesota that are sensitive to that. Anybody here from Rochester area? I have to think, what was it, southeast? Southeast. Okay, so in Rochester we have some issues with the fractured rocks and so forth. Okay, and then any other questions? Okay, so the water does really form what we do, where we live, and so forth. And then we talked about the precipitation rain patterns. That it's a just very quickly. I try to do some research on the site, and one of the parts we're interested in is how does the pattern of the rain impacts the pattern of the stream flow. It sounds so simple, when it rains, it's got to go somewhere, it goes into the stream, but it's really fascinating how the pattern of the rain influences the pattern of the stream flow and how that impacts the water quality in the lakes. So everything connects with each other. And of course, we've got to remember precipitation patterns, not only they change through the time, but they change for locations. So Minnesota does not have a uniform pattern of rain. If it rains 1 inch here, does not mean that it's raining an inch in northern Minnesota. It would be totally different. This is a map that shows what is the annual average that would depart from normal. So if you look at the past 30 years and took an average and said it rains maybe an inch a month in July or something like that, this is looking at, for that particular year, how different that particular site was from normal. So you can see the whole Minnesota, it's always shifting. It's always moving. Things are always changing. Okay, so this was our very quick hydrology reminder, really. It's not even justified as a review, but just a quick reminder of the 4 objectives that we will use tonight. And really the takeaway, and I did not pay anybody to look at those articles, but it was interesting as you were saying it. The takeaway is to remember that water has energy, and that energy creates action. The water moves, it moves things, it cuts through things. We want to remember those things. Okay, good? All right. So now we can jump into stormwater and talk about stormwater and what it does for us. Well, we're going to have 4 chapters we're going to cover tonight, right? We're going to have a chapter 1, as I said in the beginning in the agenda. We're going to talk about the big picture. What's in the big pictures? What are the big issues? Then we'll talk about the problems. You want to know, by problem I mean is, well, what does stormwater have to do with anything? What does stormwater have to do with water quality or watershed management? How does it connect together? That, we'll talk about that. Of course, our favorite part of talking about solutions, the exciting stuff. And then we'll talk about how do we make a plan, and that, what did we say? There's no silver bullet. There is no magical BMP. We've got to use a number of different BMPs to solve our problems. Good. What I was thinking of, the big picture, I was saying, when I tell you the big picture of water, what sort of an image comes in your mind? What do you think about when I say, what's the big picture about water? A water cycle. That's a good one. Life? That's absolutely. Water is life. Isn't that some saying somewhere? I'm sure. So I thought, it was a couple of years ago. A group of scientists from MIT had put together a graph that I thought was really carried this message very clearly. And that was, I said, okay, if we look at Earth and we take all the water in Earth and we put it together, it makes that size of a drop relative to the Earth. So if we took all the water on Earth and put it, it will just make that small of a drop compared to the size of the Earth. That's all the water we have to deal with. And out of that water, about 97% is salt water. So we have just a tiny amount of fresh water. What's interesting, even about 1% of that, just a fraction of that fresh water is available as what we usually refer to as fresh water, which is lakes and swamps or wetlands. The rest of that is in groundwater or frozen in some ice cap somewhere. So what does this tell me? I look at this and all of the water is that much, and the amount, and I can only use a very small fraction of that as what we call lakes and what we're dealing with. Yes, sir?
You're saying that dot represents
All of the water. When you look at the volume of the water and the size of the Earth. Yes. This is relative to the volume of the Earth. Yes. And I looked at it and said, wow, maybe we do have an issue. Maybe the question is we have a finite fresh water. We have a finite amount of fresh water. We're not dealing with an endless resource. Not only that, not only we have a finite amount of water, but we have a finite amount of fresh water that is facing a few stresses, a few pressures. One of them is the demand on water. Fortunately, our population is growing. We're growing with population. Minnesota is growing too. Not only the population is growing, but the rate of demand for water is growing faster than the population. So there is a discrepancy in here. Not only the population is growing, but the demand is growing faster than that. So we're having a discrepancy. So this is going to put additional pressure on the water. We also have an issue with eutrophication. You all have talked about eutrophication already. It's the process of ending up with too much nutrient in your surface water, right? So when you do that, we don't usually end up with that clear blue lake. It turns into more of a greenish, grayish lake. And we don't sort of like those type of lakes. We like them a little bit cleaner. In the clean, by I mean less nutrients in the lake. When we look at the map of the U.S., and this is from 2000, I haven't updated this for 2010, this map, you can see the darker it is, you can think about eutrophication. Another analogy is they call it mature or older. So you can see the more nutrient-rich the areas are. So we have a real issue. There are a lot of surface waters that up to 20 or 30, 25%, or more than 25% of the watershed area or the communities where the eutrophication that have surface water that's eutrophied. Yes.
I wouldn't expect Montana.
I'm sorry, did that answer your question?
I guess, yeah.
I hadn't thought about that. That's right. Yes, ma'am.
Well, it's kind of related. What
Yes.
primary things do you use to explain those patterns? Like, there's not really, I see that they're like sub-watersheds, but there's not really clusters around developed areas. Per se, they're kind of, how do you explain this map?
I am not 100% sure. What I can guess on that is that this list is developed based on the ability to go out in the natural area and sample the lakes and test it to see if it meets a certain standards. And if it doesn't meet that standard, then you list that lake with your agency, with your state agency, as what we refer to it as impaired water. So this is, yes?
Well, I just want to say that each of those dark areas represents a different major land use. So in Montana, a lot of it is grazing land, right? So you'll get nutrient transport from cow poop. In Idaho, they have one of the largest phosphate mines in the world. In Florida, it's citrus. But it's all about human land use in those areas that transport nutrients from the land into the water.
Yeah,
Yes.
I was just wondering about what it's,
Be different in each state.
What it is in Alaska, that's fairly shocking, I mean, it's all close to the sea, I think that's the border.
I think those are the borderlines.
Oh, that isn't.
But you're right. They could also. I was saying the other thing is that if we have investigated them and if we know, I mean, there could be a lake out there or a watershed out there we haven't tested, and therefore we're not aware of it. It's a good point. Okay, so the message is that we have that finite picture. Remember that globe with the little drop? We have that little bit of a drop of water that is facing demand, it's facing eutrophication, and we also have this changing climate. How many here still do or used to listen to Mark Seeley, state climate? I think we're so lucky in Minnesota. It's always, it's just fun to listen to him. And I really encourage you to go to his website. Just type Mark Seeley, state climatologist, will take you to his climatology group website. He's got tons of information that he's freely sharing with everybody, and we use it all the time. And he's got an excellent way of explaining how things are happening, how things are changing. That we just look at the data and we'll see certain trends. And bottom line is that it's a changing climate. Things are changing. To plan for next 30 years is not simply looking back and saying, let me see what happened in the last 30 years and I'll plan it for the next 30 years. Doesn't work that way. We need to be conscious that things are changing at different rates, so we've got to plan accordingly. So the water is also being impacted by that. We know our rain precipitation, what's happening with the rain pattern is that maybe the amount of rain is not going to change from year to year, but how much, you talked about getting 6 inches or 9 inches per 24 hours or 1 hour or something. There was, what we know in the future is that that's what is going to happen. We're going to have an amplification of the rain events, all maybe happening once, and we have a long time of a drought period in between the rain events. So those things we want to be conscious of those. So those are the 3 issues that our finite freshwater is facing. So we have an issue, it seems. We have an issue and we have some urgency. And then you ask the question, well, why do we care? Well, we care because we know if we don't, excuse me, if we don't protect and manage this finite amount of water, we're going to be in trouble. And we care about it because we care about water quality. We like to fish, and we like to eat fish, or lots of other things that oceans and water offer us. So that's our motivation. Our motivation to care for stormwater, to care for water quality is because if we don't manage it, if we don't protect it, we will not have it. So with that, yes.
When I see the term freshwater, I think it's non-submersible.
Correct.
So is that what did you include the ocean in that or not?
Yes. Everything is in this water. If I took that water and put it in this column, that much of it is salt water, and only about 3% is fresh water. And if I take that fresh water, out of that fresh water, actually I have about 80-some percent, or close to 90% in groundwater and ice.
But I think part of what's confusing about this graph, or this image, because I saw this image too and I went, what? Is 75% of the Earth's surface is covered by water. But if you look at volume of water compared to volume of land in the planet, that's the ratio. Right.
Yep.
Yep.
It's just, it kind of gets you. And one of the things I wish I had thought of that. Okay, so are we good for a short assignment, or what do we call it, test? Individual. Let's take a few minutes. I thought maybe, and whatever. This says 30 to 50 words in less than 10 minutes. But if you do it within a minute and a half, it would be excellent. Just to take a moment to reflect on what we've talked about. What are the issues that are facing our finite freshwater resources? And try to say it in your own words. What if you reflect back on what we've talked about on the articles you read, on the articles that you investigated, how would you summarize what we have talked about in the past half an hour or so? And how would you go about prioritizing if you come up with 1 or 2 issues that you found very touching? Okay, how about we say take a few minutes, that volume or that amount, it's just an analogy. So so we're just assuming that there is finite fresh amount of water, and I think most of us would agree with that. All right, would you like to go, if you like to?
I would. of waters and how they're allotted.
Good point. Maybe one more or so? Yes?
I think one of the top issues that's going to be facing us is the distribution of water. We've got a desert in places where there's millions of people trying to make a living that used to have water, but don't have water anymore. And then we got some places where they're getting too much water.
That's true. So distribution? Yeah.
Distribution is big, agriculture is big.
Okay.
Fracking, tar sands, agriculture.
Okay. Excellent. So far we already have listed like 5 issues, because we talked about eutrophication, climate change, demand. You talked about prioritizing where the issues are, distribution. Any more? Yes.
Yeah, it's wearing me out thinking of keeping this water clean.
Yes.
It seems like an enormous job.
Yes.
For as much as it's being changed, we can't allow it to be changed that way because the price of getting it back is huge.
Yes. Absolutely. Very good. Real question is that can we handle it? Can we address the issue? At least from my limited experience and my knowledge, absolutely yes. We can land the person on the moon. We can do this, no problem. We have the solutions. It's doable, and we can do it. No one said it's cheap or easy. When I said this is cheap or easy, but it is doable.
You can get NASA to get a man to the moon, but I can't get my lake association to do anything. So.
I didn't say it was easy, but is it doable? Yes. We have the technology to do it, I believe. Okay, anything else? Yes.
The question I'm wondering about is there was an article about the lawsuit from White Bear Lake in the paper this week where the DNR is being sued by the homeowners around White Bear Lake on their water lake levels. And I'm really curious about the Minnesota's really used to having a lot of 1-inch rain events, and that we can get all of our aquifers to recharge. But now we have the added problem of having so much pavement everywhere, but then having fewer 1-inch rain events and like big ones like 5-inch rain events. So I'm just wondering how does the Met Council of the Twin Cities keep our aquifers getting recharged when at the same time climate change is going to cause more evaporation from lakes, as well as bigger rain events that are harder to like soak in. So I'm curious whether you think the Twin Cities how easy it will be to maintain our aquifers given the different rainfall patterns.
Very good. Do we have anyone from Met Council here? No? But I said, because actually Met Council, if you, just as a resource, if you go to Met Council's website, they have a very in-depth groundwater study of the metropolitan area, which they've spent years developing it. And they have wonderful atlas or groundwater maps there that will show you, and what you're talking about, White Bear Lake, the rate of the amount of water they've been pumping, and the level of the lake going down. They talk about that. And I'm not answering your question exactly because it is hopefully part of it we'll talk about tonight, because there are a number of different things we have to address. Yes. And
a year and a half ago or 2 years ago in Edina, there was a speaker from the U of M, a woman who was working on the Legacy Amendment. I don't know if you know who she was. And she was talking about Minnesota's water and saying that we don't really know how much water we have in our aquifers, or Minnesota doesn't really know how much water we have. Is that true?
I'm not.
She's a colleague of yours, so you probably should.
I mean, I'm.
Well, I thought she was talking about aquifers also. Oh, that's ground.
Yeah, we don't know.
Okay.
The DNR is responsible
Yeah.
The DNR, this is for the tape. The DNR is responsible for monitoring groundwater and for permitting large extraction wells, but we really have no idea how much groundwater is in the ground, and We don't have a good handle on how much is being pumped either.
Yeah.
And if you're interested in this, the Freshwater Society just published a really extensive report on groundwater, and I'd be happy to bring
Oh, that's
copies in
right.
for everybody.
I should have
And she
mentioned
also
freshwater.
said no water flows into Minnesota. We don't have any water flowing into our state, big rivers and stuff, but a lot of flows
Yeah,
out.
downstream, yeah. We get to set the destiny for ourselves.
Yeah,
That's great.
100% of Minnesota's water falls out of the sky.
Very good point, and we'll talk about that later on. Yes, maybe one more comments, and then we'll go.
Well, this is a sideline question about the aquifers and trying to determine how much water are in them. Because I know in California, there's a lot of subsidence in the Central Valley because they've had so much pumping from agriculture. So it's like, I'm going to say it's got to be at least 20 feet plus, and they've been continuously finding that the ground is keeping to sink in the Central Valley. So I feel like that would be a way to maybe measure, because there are communities on the periphery of the Central Valley that are becoming too saline for the communities. Like, if there's not something done really fast, they're not going to continue living in those little farm communities anymore. But I don't know if there's any, I mean, I'm just thinking off the top of my head, but how would you measure the groundwater is what I'm trying to ask.
The only way I know to measure groundwater is to measure wells, is to monitor wells. Go, Bill, go.
All right.
There's a satellite, I read about this last week.
Oh, yes.
There's a satellite that can measure, by measuring density of the earth, can tell how much water there is.
Wow.
And they're starting to
Fascinating.
map.
Yep, you're absolutely right.
It's just happening now. Like, if you look in the DNR's map database, you can't find maps of groundwater. You can find maps of potential impairment to groundwater, but it's like, whoa, we don't know that at all.
Okay. Would you mind if we
Totally
continue?
lost control.
No, it's okay. If we can keep your ideas, it's great. And we're going to build on it a little bit more, and I hope, if you don't mind, we'll build on those ideas. Would you like, go ahead, please.
I need to know.
Yes.
When you say, can we manage it, are you talking about in Minnesota or worldwide?
That is
Because
just
worldwide, we cannot manage it.
in Minnesota?
In worldwide. Minnesota's blessed. Other parts of the world are damned.
You could have an effect on, the UN, or, go to your ambassador or something.
I mean, the fun about environment is that the difference of opinions. I mean, that is the fun part of it. And having done this for a few years, I see it as a very doable thing. Otherwise, there wouldn't be any incentive to wanting to do this if there wasn't a solution.
In Minnesota. I
I think everywhere. I think worldwide. I think we can absolutely do it. It's not a problem at all. We need to have coffee, good coffee, and we'll talk about it.
Probably unique to the environment at the U. They're studying a lot around the world water supply and how to make agriculture more efficient in terms of using much less water to grow food. But they have a lot of studies on the Institute of Environmental Website.
Excellent. The director is John Foley, and that is the one. We're so lucky in Minnesota. We have the Freshwater Society. We got John Foley. Anyhow, so let's.
And there are lots and lots of people grappling with exactly that question.
Yes. Okay. So that was a good kind of a starting, and I know we should have been done some time ago, but it's just been fun. We'll continue. So that was the first chapter. Don't mind the time that says 6:30. We're a little behind, but so that was, I guess, for me, it's important to take it again, stand back and say, okay, what are we talking about? Do we have an issue? And I think the articles you read, the discussion we have had, and the points you're bringing up does show, yes, we have an issue that touches all of us. It's important for us that we want to deal with it, and it has, and we can relate to. So that's the big picture. We have a finite amount of water, and we have a number of issues that it's facing. So we go back to the other question. Okay, so I've sold it to you that we have an issue, it's urgent, but what does stormwater have to do with it? Who cares? How does stormwater come into the play? How does it impact water quality? That's the next thing we're going to talk about. Okay, so what are we looking at here? The water cycle, right? And I said what's nice about it is that we know it's a big discussion. We know there are issues everywhere. But fortunately, again, we're just talking about a small portion of the water cycle. We're just going to concern ourselves for a little bit and be selfish and say this is what's important. That's what we're going to focus on right now. We're just going to go look at how the water moves downhill. That's what we're going to talk about for the next half an hour. If that's what we want to talk about, if we're going to talk about how water moves downhill, and we know water moves downhill through streams, creeks, and rivers, and so forth, so then all of a sudden it becomes really important. A measure for stormwater, one of the main measures is, well, how much stream flow you have. You always hear people talk about stream flow. You know, you put it in the cubic feet, you put it in the gallons, all these different units and everything, acre feet and so forth. There's an interest in how much water is constantly flowing. So one of the things we're going to learn, first of all, is that the rain impacts the streams. And we want to know so we measure the streams to have a handle on how much water is flowing. There are different ways of measuring the streams. You know, you can have an instrument that has two pipes that goes into the stream. And of course, the water sits here. As the water comes up in the stream, it's going to go into this well or a pipe. And as the water comes up, it can make a mark for us and will tell us what the depth is. And we calibrate it on the depth of the stream, and we figure it out. And then we end up, everybody in this science loves these plots. You know, you constantly want to see how the water is moving. If you go to the USGS website here, Army Corps, if you go to Army Corps, there are a good number of live stream flow monitoring. You can go out right on the web and see right now how that stream is flowing. It's exciting. So you can look at that and you can find, so we constantly want to measure how the flow in the water in the stream is. And that's important for us. Why is that important again? Because we said the rain impacts impacts the stream. Let me start over again. Let's say we have our rain, we have our clouds, and it starts to rain. So how do I measure the stream? Have you all talked about this already? If it's a review,
A little bit last time.
you talked about the hydrograph and how you measure the stream. Good. So this would be another review, so we can go quickly. So let's say I'm standing in the stream, starts raining. If I start measuring how the water that comes up, that's how a normal, if there's anything normal, a stream will behave. As it rains, the stream starts, the level of water in the stream starts coming up, and when the rain gets to the maximum, it goes up a little bit after that, and then after rain drops, it gently drops off also. This is what we refer to as a hydrograph, a typical hydrograph, which is never typical, depending where, if you're up on the mountain, down in the valley, it's always different. But typically, this is what we consider a hydrograph. So we're always talking about hydrograph. And many things changes the shape of that curve, you know, depending on your soils, how much water you had. We heard numbers of 9 inches per hour or maybe 2 inches a day. All that can shift that bell either one way or the other, or the peak, or make it higher or lower. Those are all important. So what kind of vegetations we have? Will it make a difference if I have 10 acres of nothing or 10 acres of forest? Which one do you think was going to have produce or generate more runoff? The area that has nothing on it or the area that has lots of trees and lots of roots? I'm sorry? Nothing. The one with the tree and roots, of course, is going to absorb the water, and the one that has nothing on it is just going to generate a lot more runoff. So what we have on the land is going to impact that runoff also. Let's make it very simple. Let's take a look at two scenarios. We're going to look at a typical annual water budget of an area that, again, that's what we say normal, something that we haven't impacted much. We haven't built any high school there. We haven't done any mall. We don't have any clinic. It's just a very nice out there, something, you know, some nice forest city. So we're looking at this, and what happens with water is, as we get the rain, about a third of it infiltrates its way into the ground as that turns into groundwater. Then we have about a third of it, or 37%. Of course, the numbers are all suggestions, right? Things always change. But in this typical, we got about a third that goes up as evaporates or transpiration. through plants or just simply evaporates into the sky. But what's important that I want you to see is that about only 1% or so, or less than 1%, is generated as what we call runoff or stormwater. That means lots of it goes in the air, lots of it goes into the ground. Some of it goes inner flow or right beneath the surface of the earth, and that's what actually feeds most of the creeks and the streams. But just a very small amount is generated on the surface because the rest of it is being absorbed or evaporated. Now we go to the other nice city, but here we have hospitals, we have police stations, we have shopping centers, we have streets and so forth. We have done some impacts. Quickly, what are some of the things you can see that we have impacted that you can see in this picture? What are some of the things that are not here but are here? Number one, vegetation. We have less vegetation here. What do we have more here that we don't have here? We have structures, hard surface, so the water cannot penetrate into the ground anymore. So all of a sudden, our groundwater from 30-some% goes down to 15%. Evaporation actually reduces a little bit because we don't have the plants that fan out the water, so we have less water evaporating. So all of a sudden, this number changes from something 1% or so upwards of 20 to 30%. So by changing our landscape, we're generating more runoff. Are we making more water? We're not making more water, right? We're dealing with the same amount of water. It's finite. But we're putting more water into the runoff, so we're generating more runoff. And that's what we're going to be concerned with. So it seems that stormwater, the one that we're dealing with, we're talking about excessive stormwater, the stormwater that we generate through impacting the landscape. All right. So you already know this already, so it's easy to say. So what is this? A hydrograph. So when I look at this, what am I looking at? Right. So what I'm looking at, I'm standing in one place in a stream. As the time goes by, I'm looking at the depth of the water in the stream, and this is how it behaves under normal condition after a rain, right? So let's take this hydrograph and let's put it in these two cities that we had, or two locations, and see how it behaves. That's what we're interested in. We want to see what happens to a hydrograph when we go into two different places, and we look at the hydrograph. Boom, wow, there's a little difference here, isn't it? Someone mentioned flash flooding, so we'll maybe look at this and see if we can figure out what that means. So here we are in our normal conditions, so we have our rain, so it rains and the water gently goes up because we only have how much? About 1% of water produced as surface water runoff or stream flow, and that's what we're going to get. But here, what did we do for our water runoff? What did we do here? We increased it. We increased it a huge deal, so that water has to go somewhere, and where does it go as a runoff? And if I'm standing in this stream, what do I experience? I get knocked over, exactly, because water has energy, and that's important to remember. So how much water so number one, I'm going to have more water. But is that more water distributed equally through the time? No, I'm going to get a gush of water because there's no place for it to run, there's no refuge, it's going to hit the surface, it's going to come down. So all of a sudden, not only I get more water coming at me at once. So those are the main difference between those two issues. So now you all look at this, you know instantly what we're talking about, right? So this line, when I point in this line, which line is this? This is from this good city, right? I mean, they're both good city, but more natural. And when I look at this line, I'm looking at where I have impacted the landscape and I have generated more runoff. I didn't create more runoff, but I just rerouted more water into the runoff. Good? So, and this is the area, and this is a highly technical term I use. I say glob of water here. This is the glob of water that we have to deal with. So when we talk about stormwater management, that is what we're talking about. How do we deal with this excess amount of stormwater? This glob of water, because it wasn't there before, now we have to deal with it. How do we deal with it? All right? Yes, ma'am.
I'm just from a mathematical concept trying to understand why there isn't more area under the curve differential. I mean, really this red curve is only about water area under the curve, and yet it's 30% more of an increase. I mean, I'm just
Very observant. Very good.
conceptually it's not working for me. I'm trying to figure out why.
You're absolutely correct. I did not do the math. I did this for graph. You're absolutely correct. So if I went out there and measured the area under my graph here, and I measured that, and if I increased my surface runoff by 10 times, will I have increased this 10 times? Probably not. Good point. I got to make a note of that. Good catch. However, it is true though. It's a good point. Because the ratio, as we said, the more rain we get, we're going to have more stream flow. Okay, good. Yeah, one more question.
Wouldn't the two areas be equal?
Well, we didn't make water. No, it's not. It's this runoff, so we have actually 30% versus 1%.
Absolutely.
So,
Yeah, that's how much of that water makes it to stream. With one thing would you agree though, but one thing we try to exaggerate and show that we get that water up front. When we impact the landscape, what we do end up doing for sure is that we do get a good amount of that. We get this blob of water up front. The flash flood we're talking about, that's what we're talking. This coming downstream, and there's nothing to do, there's nothing we can do about it unless we have planned for it. Good? All right, let's talk about it. So this is the culprit. This is the one that causes the problem, this glob of water. So I'm standing in the stream. As you said, the water is going to come and hit me. It causes three main problems. And I'm sorry I'm going to keep repeating these three main issues. Because all of a sudden what do I have? I have too much water that is moving too fast. Too much water moving too fast. And it goes down. It has energy. It cuts down the dirt. It cuts down the earth. It washes the pollutants off the surface. And it degrades the water quality. So those are the three problems that the stormwater has. And that's how stormwater gets connected with water quality. So this excessive stormwater runoff, it creates three problems, which is what? Too much water, quantity, it moves too fast, it's the rate. The rate of water going downstream is much bigger. And also, as it goes down, it washes down everything, and it causes erosion, it degrades the water quality. Good? Don't worry, we'll keep repeating that until we get it. See, we're repeating it already. Anybody can guess what this picture is from? Duluth. You've seen it. So again, we coordinated just fantastic with these articles. So the problems of stormwater and water quality is what? It's these three problems. These are some of the consequences of these three problems. We have too much water. You mentioned, I forgot who mentioned about the impact of water quantity on infrastructure. The infrastructure simply cannot withstand that extra glob of water that's coming down. And the rate, when you have too much water moving through the streams, it's going to cut through the streams, it's going to cut all that dirt and wash it downstream. And of course, if it washes downstream, it's going to go into our lakes. And you remember that map of the watershed with brown points, meaning getting too much nutrients into our lakes? Well, this is one of the good source. Actually, non-point source has become the largest pollutant for our surface waters. Okay, how are we doing? Are we doing good? All right. So, how do we degrade the water quality? Okay, let's talk about that a little bit. I said there are three problems: quantity, rate, and quality. But what's interesting about quality, you can really actually argue that quantity and rate is also part of a quality, and we'll talk about that a little bit. So we just like to always categorize things, and sometimes it works, sometimes it doesn't. But let's look at how we can go look at all of them as a pollutant. So if we look at it as a pollutant, say, okay, how does physically we can pollute, the stormwater can pollute our lakes? Well, physically, it washes the sediment down, and sediment, for tonight, we're going to consider the number one enemy. Sediment in water is just not good. Basically, there are other things that we can do in the water. Physically, we can pollute the water. We can change the rate. That's a physical characteristic we can change. We can change the turbidity. We can wash down stained water, so that's going to create clarity of water. We can change the temperature, the quantity. But having sediment in water is the physical thing. It's a nuisance for a fish. Imagine if I were, I imagine if I were a fish, I'm trying to breathe the water, and you got all this junk. Can you imagine having so much dust in this room that's going to plug our lungs and so forth? It's the same thing. It causes the same difficulty, stresses the fish and the living in the water. So having the sediment is a physical pollutant, example of physical pollutant. The sediment not only is physically a physical pollutant, it can also impact the water chemically, because sediment with it carries a lot of other things as well. It acts like a train or a truck. Not only it moves, but it carries lots of other things with it. A lot of nutrients get attached to the particles, to the sediments, and as the sediment goes down, so does the nutrients like nitrogen and phosphorus. And you all know about nitrogen and phosphorus, right? What's an example of phosphorus? Fertilizer, right? And we don't want excessive fertilizer, because we talked about it in one of the states. Someone mentioned it creates fertilizers, so it pollutes the water. So in the sediment, we have automobile on the roads. Every time we stop, we wear out a little bit of that disc. Of course, it's got to go somewhere. So we have petroleum, we have copper, we have everything else. These are all the chemical components that can attach to the sediment and go downstream. So we can have physical pollutants that changes the water temperature, or just act of having sediment in the water, and we can chemically or chemical pollutants, which is all the stuff that gets attached to the sediment. How about pollutants or biological pollutants? Sometimes the things that we love and adore are the ones who cause the problem. The pet waste is a big issue. There are many neighborhoods and many watersheds that the waters are just getting contaminated by the pet waste. How many of you folks have experienced going to a lake and the beaches are closed due to bacteria? Lake Hiawatha. We get, they look beautiful when they're flying, but when they're in the water, they're a nuisance. Even though they look nice to look at, but those Canadian geese, sometimes they just bring too much bacteria into the swimming beaches, and we have to close it down. So that's an example of a biological pollutants. And the Bambi even. Nowadays we have more Bambis running around. You can never have a garden anymore.
Leptospirosis is a big one from deer.
That's
deer, I believe.
Good example. Yeah. So, and this is just I put this here because I know the slides say the date from last year, but they're really updated. So I just put a lot of the information here. We won't talk about it, but it is, if later on you go to the slide, this is just looking at the size of everything. So everything we talked about gives you a relative of the size of where they are. Okay, so these are the three type of the, these are the three examples of the pollutants. We have physical, chemical, and biological pollutants. Yes?
The standard water filter, like if you go camping, what does it filter down to that's smaller than that?
Good point. Actually, this is sort of a line. Yes, this is sort of a line in most labs. So when they talk about dissolved, anything smaller than 2 micrometer is considered dissolved, so that the filter was separated, and everything that's sitting here is what's, I'm sorry, anything up here is the dissolved in the water. So that's what you separate. So this would be the solids, and everything else here would be dissolved. Okay. How do we minimize these problems? So we talked about lots of problems. I showed you a lot of not very exciting news and everything else. But can we solve the problem? For tonight, we're going to assume we can solve the problem. Okay. And the thing is, actually, this is not something new. We've been talking about these problems for a long time. This is from 1970s when we passed the law that said by 1985 we're going to have everything back to normal. So we've known about these issues for some time. And I think one of the first things we have to do, we've got to start, we have laws, and we have implement our laws, these drivers for us to do the right thing. So this is the Federal Clean Water Act, just showing you that way back then in the 1970s, we knew what the problem was, and we set a date to correct things. Then actually since 1970s, or 80s actually, we started talking about what is considered green infrastructure, or the greening up the environment, everything else, which is really talking about, well, how can we solve some of these problems? They went back and they looked at these numbers and they said, what did we do wrong that all of a sudden we have all these issues? Flash flooding, we have the issues with the beaches, we have the issues with the chemicals in the water. And they said, well, maybe it's because what we have done, we have changed the landscape to a great extent. We have changed the landscape, we have changed the hydrograph, and now these are the consequences. So what the green infrastructure is talking about, said, well, maybe the way to solve the problem is to restore natural hydrology. And that became the concept or the driver for this whole idea of solving the problem. Why don't we just mimic the natural hydrology? Why don't we just restore the natural hydrology and see if we can solve the problem? And that actually in Minnesota, just not many years ago, we decided the same thing. We said, you know what? Things are going too fast, as you had mentioned. Things are changing much faster than we can correct it. So we better stop now. We want to say from here on, when we do a development, we're going to approach it with a low-impact development, meaning we're going to minimize our impact on water, on the environment. We're not going to degrade water quality, and we're going to mimic a site's natural hydrology, right? That's how we decided to do it. We're not, remember that big hydrograph? We said what we basically are saying, we're going to bring that big hydrograph down to the small one. That's what we're going to do. We're going to mimic the natural hydrology. So, from problems to solutions, I guess I am simplifying it a bit, but I absolutely believe that it is the case from problems to solutions. Yes, we can do that. We can simply just mimic natural drainage system. And we can solve the problem because we can bring that extreme hydrograph down to the normal one. Okay. If all it takes to mimic the natural hydrology, I guess then the next question becomes, well, what is a natural hydrology, right? How can I mimic something if I don't know what it is? And so that's what we're going to do. We're going to take a couple of minutes or a few minutes and talk about it. What is a natural hydrology? If I went out there and let's say this is an aerial photograph. This is taking a photo by a plane. I'm looking down. I'm looking at this place. This is my natural drainage system, right? This is my natural. Actually, it's around Brainerd. Just happened to be from. I'm sorry. Yes, it's all the beautiful lakes there. So if I'm looking at this is my natural. So my question would be, well, what makes this tick? How does this thing work? How does this system work? What are some of the components of this system? Well, it's easy to see, as you said, the first thing we're going to see the lakes. The lakes are part of the system. But this thing, okay, it's just going to come all at once this time. Knows you guys know everything, so it's going to go quickly. Okay, so when we look at this natural system, what we have is a landscape, right? First of all, we have soil, right? We have the ground, we have the trees. That's our landscape. We have our vegetations. We have this background, this landscape, this natural landscape that includes forests, that includes permeable soils. It includes soils that can allow infiltration of water into the ground. That's the natural background of this landscape. Then we look closely, then we have low spots. We have these places where water, what does the water like to do? Go downstream. Water can find its way into these gentle streams, and it can find its way to the wetlands or swales or pools or ponds or floodplains. So water has a place to go. We have these low spots or puddles. And then we look at all these puddles, all these wetlands, or maybe they're connected to each other by creeks, by streams. So we have what we call a conduit system, something that can connect the one low spot to another and move the water. So the water gets temporary storage here, sits there, fills up the pool of puddles or whatever it is, and then when it gets to a certain level, then it goes into the stream, and from the stream ultimately finds its way into a lake or a sea or an ocean. And that is our big storage. So what are these? Each one of this is what? One of the main components of our natural drainage system. So if I looked at the landscape, and if it's lacking these two, would that behave like a natural? Would I be able to mimic natural hydrology? All right. Barely. You answered the question. That's all we're going to be doing for the rest of the evening. Talk about how we can bring some of this function back into a landscape. And every time we do that, we get closer to that, to mimicking the natural hydrology. That's all we're going to be doing. These are all solutions. The solution is to bring these functions back into the landscape so we can have our natural hydrology. Okay, let's see how that works. Well, let's see if we can do it. This is a real surprise. This one is going this way now. Okay, so we said these were the natural components of a natural hydrology. So what would be the counterpart in a constructed area? Let's say I'm a developer. I'm going to go develop, I don't know, 2,000 units somewhere. Big developer. Well, you know, will I be able to mimic the natural hydrology? Well, obviously, absolutely not to the as the nature would do it, right? I mean, it's never as good as nature, but I can copy it very much so. I can be very close to that natural hydrology as long as I have the same functions that these components bring. So for landscape, I want to make sure I have a green space. I want to make sure I have the soils that can allow infiltration of water into the ground. I want to make sure I have trees, right? It's sort of hard to say I'm going to have a natural hydrograph if I don't have trees in my landscape. Biobasins, rain gardens. How many of you have heard the term rain gardens? I know this group is all right. So all we're talking about is an area that can temporarily hold the water, same as those puddles or the low spots. How about conduits, swales, pipes, culverts? Those are all the systems that can take the water from one spot to another. If we do it right, they can basically do the same function. And of course, water quality ponds. How many of you have a water quality pond in your neighborhood? Nobody? Wow. All right. Good point. Good point. Well, you may have. On the highway, actually, I think this highway, if you go up the ramp, there should be a pond in the middle of the ramp. Those are the water quality ponds. We'll talk about what they do besides acting as a storage. So this is what the message is. If we can mimic the natural hydrology, we can solve some of the problems. So these are the components of a natural hydrology. These are the counterparts of a constructed hydrology. Yes, ma'am.
Well, with all the drainage tile in the state of Minnesota and all the stuff we've done to move water around already, how do we even know what the natural hydrology is?
Very good point. That's a very good point.
Maybe it's more important what isn't. Getting closer, like we know what isn't working. And so, I mean, I feel like you have this frustration.
So no, that's a very good point. If I have tiled the system, so the water hits my landscape, and what does tiling do? It's basically, I'm going to remove this step here, or these two steps. I'm just going to get the water from landscape down to my stream or lakes very quickly. So I've removed this couple of functions. You're right, couple of functions. So if I were going to a landscape like this, oh, the water here just missing a couple of functions, then I would need to think about how I can bring these functions back, how I can daylight some of the tiling system, maybe hold it temporarily behind a road or something, and I can daylight the tiles, let the water go into the ditch, let the ditch build up with water, and then overflow the road, and then go downstream. That way I've slowed it down so I don't have a direct access to the pond.
Also, historical photos and historical maps are extremely great to show people.
Good.
You get a 100-year-old photo that really shows what things used to look like.
And I don't think there's any push to restore the original hydrology, but you can mimic natural hydrology that's appropriate for that landscape. But we're never going back to the original hydrology.
Very good point. I didn't want to follow that, but it's such an important point is that one of the things we started by saying that we have a changing climate, right? What we're going to look at in the next 30 years, it's not necessarily a reflection of what was 30 years ago. So what you said is so important is that not to get wrapped up into mimicking what we think ought to be, but we got to figure out what is best going to work for us. Because what we saw 30 years ago, it's not going to repeat itself in the next 30 years. So that's a really, thank you for that. That's very good. Okay, so again, another review. So I'm just trying to get the point. So this is natural hydrology. So we have a landscape. So let's make this quickly. You give me an example of some of the parts of the components of a natural landscape. What would you find here? Hills, yes. Right, exactly. And what would you find in the constructed? Right, you do plantings, the green space, and pervious trees and so forth. How about low spots? Right, with the rain gardens. So we make rain gardens here to make up for lack of, because we don't have puddles, we don't have the wetlands, where we bring some of the functions back into it, because we cannot have what we've lost, we've already lost. Conduits, it's the same idea. I'm just going over what we talked about, so how we are going, this is what we're talking about. We want to bring back the functions that we don't have in that landscape. And that's how we can get to that lower hydrograph. All right. A puddle. You know, it's a very good question. Actually, if you went, okay, let me answer the question. Puddle would be any low spots on the surface that can hold some amount of water. And it has a huge impact on how the water flows. I used to work for a city, and our city engineer used to tell us when they redo streets, you know, how they go, not necessarily reconstruct the street, but resurface the streets. They go back, you know, they remove the top 2 or 3 inches and then put a new asphalt. And they used to measure the water downstream. The streets, that, you know, the older street, they have lots of puddles. So after like a quarter of an inch of rain, you almost got very little water, quarter of a mile downstream. You got just a little amount of water. After they would go back and repave the road and make it absolutely clean and smooth, then they got a lot more water downstream because there were no little puddles. What did I do?
Choose the right path.
All right, thanks. So those puddles are really important in the hydrology. And so all this, because nature is never smooth or straight. Always have lots of edges, puddles, and irregularities. Okay.
And you didn't mention the natural, habitat value, when you're reconstructing things, trying to regenerate the habitat services.
Absolutely.
I'm sorry.
It brings back those functions, yes.
So, but it's hard to get enough. I'd like to have peepers in my neighborhood, but I don't exactly know if you could actually construct a rain garden that little peeper frogs would live in, because we have to go up to Worth Park to listen to the peepers. But it's a good question for me. How can you, little kids in the city can't hear little frogs, and so what would it take to actually build a wetland that in the city that kids could hear frogs? So,
good point. Okay.
The other point that you're missing on the ponds and the puddles is that's the insect level. If you don't have stable water for bees and a lot of the insects that we're trying to get for those frogs, so if you don't have a stable water system that's not moving so much that it's like flushing it out, because bees aren't like ducks. They don't just land on the water and fly away. They crawl up to it. They like actually muddy water, and so you have an insect problem if you don't have that level.
That's right. And that's a very good point. So every time you bring some of this function back, hopefully you're bringing some of that ecological functions as well. So are you sold on the idea that we can, maybe not all of you, but some of you are sold on the idea that we can solve some of this problem if it's simply designed like nature? You can mitigate, absolutely. Still, there's some catch here. I wish it were that simple. Yes, the solution is to design like nature. But, got to remember a couple of things. First of all, we have to remember the idea of the watershed, that everything is connected. We have to understand. We'll talk about it in depth. Hopefully we'll have time. We'll talk about it in depth about watershed. What is a watershed and how does it impact me? And the question we need to ask ourselves every time we're dealing with stormwater, we need to ask the question, well, where does that water that is coming on my site, where is it coming from, and where does it go after it leaves my site? It's really important to always ask the question. We can't just be concerned with, okay, I got this water here, I'll deal with it. I need to ask, well, where is that water coming from? Earlier on, someone talked about in Minnesota, no water comes to Minnesota. So we need to ask those questions because it impacts what we need to do downstream. The other thing is, can't say enough of this. It's a climate is changing. We cannot simply look back and guesstimate what happened past, it's going to happen in the future. We need to design it with that change in mind. Those are the two conditions in mimicking the nature. So before we can restore our hydrology. Okay, so it took a long time, but basically we want to talk about two things before we jump into the solution. One is the big pictures. Remember the slides about the water. It's a finite amount of water, and there were lots of issues that we're dealing with. And what is the problem? Who cares? What does stormwater have to do with water quality? Well, we talked about it. The excessive runoff creates three problems. What are those three main problems? All right. I couldn't hear it clearly, but hopefully you got those three, right? And how do we solve the problem? We try to mimic the natural hydrology. But before we can mimic natural hydrology, we have to consider two items. What are those two things?
Watershed and climate.
Absolutely. We're done. Okay, but we're still going to go until 9 o'clock. But done we're not. Okay. So those are really important. Taking a break. How about that? So let's take a quick break by doing a little quiz. You tell me. What is the question? If I gave you the answer, what are the questions? You can work with pairs or fours if you like. So I'm giving you the answer. You tell your code table person what is the question. I'm giving you the answer. You form the question. Are we due for a break? Are we okay? I'm sorry? 5 minutes? 10 minutes? Oh, okay. Okay. Peggy mentioned if you answer correctly, you get a 5-minute break.
So this is Jeopardy then?
I'm sorry?
This is like Jeopardy.
It is Jeopardy, except I didn't. Okay, we'll get back if you want to get up and stretch. We'll get back in 4 or 5 minutes. How about that? Okay, we got another 5 seconds. I think we're good.
So what's your degree in? Geology, hydrology?
Limnology.
Oh, okay.
Oceanography, but I waited a little bit to say oceanography because I'm here in Minnesota.
Yeah.
Farthest point from either coast. Almost.
So you have
Limnology, lake. So
Yeah.
limnology and oceanography. So someday I'll make it to the ocean.
and you did that you're from Lebanon, right?
No, I'm doing it in the University of Minnesota. From Iran. I'm from Iran, but at University of Minnesota.
Okay.
So it's been fun. So yeah, we haven't even talked about lakes, the most important part. Right? Ocean lakes, yes.
Fish tanks.
Fish. That's what I do. I do lake modeling, so you'll enjoy that. So I do virtual lake. Every day, sit in front of the computer, play with this virtual lake.
So do you do like mathematical modeling?
I don't write the code. Oh God, no.
Or you just use
I mean, I apply it, and I fool around with it, trying to understand. Use calibrated.
Do you do anything with Supercomputer Institute?
Yes, I do, because our program is so big. We run it at Supercomputer Institute, so I do visualization there, and right now we're trying to do a 3D. If you were to follow the, say, show me the good habitat for a fish from the beginning of the spring to the end of the fall. So you can imagine this globe of water moving through the lake back and forth.
Oh, that's cool.
I think it's cool. My kids think it's crazy, But it's fun. Okay, So how many people are confident about their question? That's good. You guys are enjoying yourself. That is the number one. If we don't have fun, it's not going to work, right? So how many people feel confident about the questions you got or the answer you got or whatever? How many people feel confident? Share it with us, please. One, two people. I'm sorry? Excellent, yes. Those are the key points, key concerns. Those are the main, the three things. And those three things are what? Excellent, because every time you have a solution, you...
Rate and quality.
And why is that so important? Because I'm telling you this is what the problem is. So if I come with a solution to you, the solution better do one of these three, right? If the solution is going to make the water, I don't know, smell nice, it's not going to, but it's not solving this problem. It could be solving some other problem. But tonight, I'm only concerned with stormwater. If it's not, it's got to do one of these three things for me. Otherwise, it's not part of the solution. Okay, so what was this one? Next time, just throw it at him.
Alex, how do we design like nature?
All right, Alex. I got the Alex. That's good. So, excellent. So you're confident with that. So now we can jump into the fun part, right? Oh, see, that was good timing. That was on break timing. Okay, so now we can go to the third chapter, which is the solutions. Now we get to talk about the fun stuff. We know the problem. We know how it's the problem created. We know what specific problem it causes for water quality, it being the stormwater. Now we're going to talk about solutions. And with solutions, we're going to look at the features, we're going to look at the function, and we're going to look at the benefit of this stormwater. This term we'll talk about more, BMPs. For right now, we'll define it as solutions. We're going to look at this whole thing and say, how does solutions work? How do we use them? How do we put them together? Okay? And of course, what's the driving guidance here? How do we minimize stormwater problem? Mimic natural hydrology. All right. You folks are going to walk out tonight. You're going to remember certain phrases over and over, right? Because those are really our tools. It's got to be second nature. We got to know it. Oh, I got a problem. I got to mimic natural drainage hydrology. You can ask us that question. So how do I do it? What am I referring to? This red line. What is that referring to? I'm sorry? Develop. Excellent. Thank you. Right. So, and what is this line I'm referring to? Natural. So when I say I want to mimic natural hydrology, as Peggy mentioned, what am I trying to do? I'm trying to bring this back down to this line, right? Got that? Excellent. So think of it as this plier. You're trying to squeeze that down. And this is the constant battle. Every single time you develop, you want to develop 1,000 homes, more power to you. But you got to remember this. You got to bring that down here. We can't let that hydrograph to be up here. We got to bring it down here. And the tools we use, and they are really tools, is what we call best management practices, or BMPs. So anytime we talk about best management practices, what's the purpose of that BMP? To bring that hydrograph down to mimic the natural hydrology. So we have our natural hydrology, we have our constructor, we have this, what was this highly terminology here? Glob of water. We got this excessive amount of water. We got to do something with it. We can only take care of so much of it. So the best thing is to minimize it or treat it on site or whatever we need to do. And we use different tools to do it. And those tools are called BMPs, best management practices. All right. Now, best management practices, they could be any practice. However, they are legally defined. If you go to Minnesota statute, you will see that it is legally defined as a proven engineered method. So a BMP, an engineer has to sign it. It has to be designed. That's very, very important. It has to be designed. We can't just apply, say it will work. No, we have lots of tools out there. They're proven. They can work. And you can divide the BMPs a number of different ways. How many of you folks are familiar with those funny curtains on the properties? Sometimes they're black, sometimes they're red. They call them silt fence. What is the purpose? Exactly. And their job, is it do we put them in place to last for eternity? Even though nobody ever removes them. But in reality, they go in for a certain time. So they're what we call a temporary measure. There's some things like the water quality pond we've set in the ground as a storage. We want them there for a long time. So they call them permanent. So there are many different ways to, again, categorize the BMPs or these tools with structural, non-structural, and so forth. The ones that we're going to use tonight, and the ones that I'd like to use, is what we call this treatment train. And all the information comes from Minnesota Stormwater Manual, which all you got to do, Google it, and it comes. And again, we're so lucky in Minnesota. We have so much research. We have many different agencies that provide lots of information. And this is all the information here, so you don't have, the material is available on the as PowerPoint, but also the original material is available in the Stormwater Manual. Yes? This particular one, Stormwater Manual, is the website is at Minnesota Pollution Control Agency, MPCA. So if you say MPCA Stormwater Manual, it takes you right there.
And just mention the minimal impact design standards.
Absolutely.
There's anyway the MPCA is trying to help cities to be able to use this a lot more everywhere else in their city. Anyway, in order for cities to have less red tape, the MPCA is trying to make it more easier for cities to implement all these BMPs through what they call the minimal impact design standards. And so if they use these BMPs, then they'll be able to get credit for all the things they have to show they're doing. But it would have to do with new developments as well as redoing streets and everything.
Absolutely. And remember, we talked about that in Minnesota a few years back. We decided that we want to mimic the natural hydrology, and we want to adopt the low development approach. And the MIDS is a way to help us to implement that approach. So the way we're going to talk about BMPs, or best management practices, or these tools, right? This is just the tools to bring the hydrograph down. These tools is using this treatment train approach, which is basically says, this sort of makes sense to me, which I focus on the function. I'm interested. I'm very narrow-minded tonight. I'm only dealing with stormwater, and I want to bring back some of those natural functions that I have lost in the landscape. So I want to look at the BMPs that can give me that function that I'm interested in. So I'm interested in the feature, how do they work? I want to look at their function, and what's the benefit? What does it bring with it? And we can categorize this of those best management practices that prevent pollution. For years I've been storing my fertilizer outside in a pile. Then one day it dawned on me, when it rains, it washes the fertilizer downstream. Would have been nice if I covered it, right? It's a pollution prevention. I'm preventing it from going downstream. I sweep the streets, and that's I'm preventing pollution to go downstream. Those are all pollution prevention. So there's some best management practices that say, okay, I've done everything that I could on site, but I still ended up with some runoff on my site. Now what do I do? Now we have come up with a new slogan. Some of you might have heard. They say, stop the rain where it falls. Oh, how does that go? I butchered it. Stop the rain when it falls. That means if the rain falls here, let's find a way to keep the rain on that spot. Help it to infiltrate into the ground, because that's what natural hydrology would do, allow the water to infiltrate. So a lot of work we do here with source control. We reduce the runoff. Okay, first we try to prevent. We prevent as much as we can. Whatever we end up, we try to control it on site, infiltrate into the ground, minimize the volume. We do that, and you can see the arrows are getting narrower and narrower as we go downstream. But I still have some runoff. This is reality. No matter what I do, I still end up with some runoff that's going to leave my site. So I want to make sure before it leaves my site, I treat it on site. So it has the right quality and it has the right rate before it goes downstream, so it doesn't create flash flooding or flooding for anybody downstream, and it doesn't impact my waters downstream. So this sort of makes sense to me, and this is the system that Minnesota is using, and that's how we're going to categorize the BMPs. Good? All right, so what's the first type of BMPs we're going to talk about, or tools, or best management practices? Pollution prevention. Thank you. So let's talk about pollution. We're not going to talk about all this one. I know this is breaking all the PowerPoint rules. I put in so many texts, but I put it here because if you go back as a reference, all the information is there. It's just a testimony that there are hundreds of different ways of preventing pollution to go downstream. Some people, I put it P2 because some folks refer to it as P2, pollution prevention. No matter what name you use, there are many ways. There are tons of different things we can do for residential. And tonight we're going to focus mainly on this part. But there are hundreds of different things that municipalities can do. And that's what we do when we do our day-long classes. We deal with municipalities of how they can improve the environment and handle stormwater. And industries, they have their own hundreds of different methods of how they can deal with their stormwater just by preventing it going downstream to begin with. And there are different ways, different methods of applying those methods. Again, I put it down here just so later on if you go, you can have access to information. Some people call it low impact development. We already talked about green infrastructure. Some people may call it conservation design, design with nature, design green. What's the point of all these things? We're all moving in the same direction. We all want to mimic what? Natural hydrology. Maybe different names, a little slightly different focus, but they're all trying the same thing. And I've just listed them on here of what the possible, different approaches are. Okay, so we said the first set of BMPs we're going to talk about are going to be what? Pollution prevention. So let's see, how are we going to mimic natural drainage systems or natural hydrology through pollution prevention? Doesn't that sound interesting to you? All right, and these are some of the things that we can do as homeowners. The first thing is public education. It is the number one. Yes, many years ago, we used to write the plan, do everything, and the last page and the last sentence says, and we will do public education. That was the extent of it. Everyone has learned that public education is a real tool. We can make things happen by educating our public, increasing general awareness, letting people know what they do on their yard has a direct impact to their lake that they go on the weekend and enjoy, or the stream, or the path they walk with their dog or dogs. Whatever. I couldn't think of another pet that I would walk with, but that's or a rabbit, I suppose. I don't know. But so public education does work. Actually, what we've something I've tried to do is to actually put a measure on it, sharing with our partners and cities. If you send your staff, we've shown by going to our education system, or not ours, or any stormwater education, by increasing the maintenance of your best management practices, you're preventing up to 1,000 pounds or 2,000 pounds of phosphorus going downstream. So putting and every pound of phosphorus that you remove is going to cost or minimize the cost. So we can put an actual dollar to the amount of education that one receives. And it might be pushing a little bit, but the idea is it has a direct impact, and we can measure that. Okay, public education. Again, another example of public education is working with the homeowners to sweep the streets. Many cities have programs where they will give you a broom and a bucket and say, you know what, thank you so much, you're in charge of this catch basins. What is a catch basin? Right, all those little holes on the edge of the streets where they can catch the storm water, puts it into a pipe, and that pipe goes where? Exactly, it goes to a creek. Maybe it goes to a water quality pond, or maybe it goes into a BMP, hopefully, but it ultimately falls into a lake or a stream. So whatever we can remove from the system that can get in there is helping to prevent the pollution going. How many of you have seen these markers on any catch basins? All right. Many cities are doing that, reminding folks, don't dump the oil here. It does go into a lake. It doesn't go to a purification system or anything like that. Public involvement. We're just talking about it. Public involvement. You cannot get anything done without advocates. That's rule number one you learn as an environmental manager, environmental whatever. It takes people to do the work. You got to have advocates. You got to get out there. Look at yourself. You are part of the group that's going to make the movement. And you were talking to you, were reminding me. You are here because you care, and it's your participation that's going to make the difference. you going back and connecting with another 5 people, 10 people, and that makes a real difference. So public education is important. It's a pollution prevention. You help people not to pollute to begin with. Cleaning the streets. Again, anybody from any city here that provides you free bucket and free broom to take the leaves out of the gutter, because by removing it, first of all, that you're removing it from going into the storm sewer system, but also in the springtime, during the freezing condition, it doesn't plug the catch basin, so it doesn't create flooding. So it does a number of different things, and many cities offer that. So call up your city, see if they offer it, or actually having the machines go and clean the streets. So those are some of the things you can, by capturing the pollutant on the streets before it goes into the storm sewer system. Does that make sense? That's pollution prevention. Real measures that we can do to minimize pollution. Why did,
Shane, I just want to
yes,
throw
please.
one thing. I was just corresponding with a scientist named Dr. Sarah Hobby at the University of Minnesota. And she's doing studies on litter fall, leaves, seeds, all that
Yeah.
stuff. And she says that in urban areas, somewhere between 50 and 100% of the phosphorus and nitrogen going into lakes from urban areas is litter fall. So, litter fall, leaves, grass clippings, seeds. It's somewhere between 50 and 100% of nutrients can be traced back to leaves.
So I thank you. It is a very good reminder that it's a real issue. Actually, not long ago, we had a class here working with the city staff on how they can design their street sweeping programs. They can, considering those studies, and finding how they can trap more nutrients before it can go downstream. Okay, this is IDDE. The reason I put that here is a few years back, this was really just for the city staff would go and do IDDE. Basically, it's, okay, it hasn't rained for 4 days. This is how, I've done this is exactly how it happens. Hasn't done for 4 days. Good day to do IDDE. What is that? You go out, you find an outfall. Well, if it hasn't rained, should it be dry or should it be running? It should be dry. It hasn't rained for 4 days, so there should be no water in the pipe. But the thing is running, so that means somebody's putting something in it besides runoff, besides rain. So you go up the stream hoping to find out who's putting what. Well, as we're learning, this is the important part. This is actually adding a lot of pollution into the system. And not all the cities have the power to go everywhere. Thanks for the smartphones and all the GPS. Now a lot of cities get help from citizens as you're doing your weekend walk. And if you see something, it hasn't rained for 4 days, and the creek is running, or the stream is running, and it doesn't look the best, it does, Oh, I'm sure they will. No, nowadays, everything is touch screen, so you never know if they do something. How many of you find yourself touching your computer screen? It's just that it takes a while, and I say, oh, wrong piece of equipment.
So you call if you see that.
Well, then there's a process. At the homeowner's level, at the resident level, basically you just take a picture and inform. Not all, but some cities are already doing this. And this makes a huge difference because this is the pollutant that's going downstream, but if you can eliminate it from the system, it saves money and it saves the environment. So this is important thing. Good housekeeping. Road salt. You've heard about it. I know me in Hard Creek Water District and Fresh Water. Everyone has been involved with this research. Eliminating this undesirable amount of salt that we put. We have to use salt, no doubt about it. We have traffic safety issues. But can we improve it? Can we be smart about it? Can we cover the salt so it doesn't get washed away? This is a really high-tech idea, It took a long, long time for us to start thinking, maybe we should cover the salt. It sounds, so those are some good housekeeping measures that we can employ. We can do this, again, as a homeowner, maybe not, but as a business, and we can do some of the things at home. What are we storing on the property? Okay. Rain. Maybe you guys don't need it. You guys are really energetic. So, what is BSD? Oh, there's no way you would have remembered it. It was one of the terms among the hundreds that I showed you on one of the slides. It's an approach. Better site design. The idea is just a quick reminder. We may call this number of different things, but what is the primary driver for all of them? There are BMPs to help us to do what? Mimic natural hydrology. Boom. And is it going to improve water quantity? Is it going to improve the rate control? Is it going to improve the water quality? If it does one of those three, all right, we're all for it. If it doesn't, it may be very good stuff, but it doesn't help stormwater. Because tonight we're just stormwater, right? Oh, everything always connects, but together. So, better site design. One of the things as a homeowner, what we can do, this is beyond maybe as a homeowner to go and redo the street, but heck, if I'm a homeowner and the city comes with the idea, hey, we're thinking of this idea that we're going to eliminate your sidewalk, or maybe we're going to expand your sidewalk, or we're going to do a number of different things. Maybe we can put some rain gutters on the sides, and we're going to make it the road to be jagged, not straight. We're going to make it a multifunctional area or landscape, and we're going to introduce stormwater system into your street. It's going to be a little different. As a homeowner, the least I can do is to be open to the idea. And if you've educated your neighborhood about this system, then it can get implemented, and you can improve the environment. One of the better site design ideas is, why do we have to have such wide streets? Why do I have to take my life in my hand if I want to cross the street? You know, it takes forever to cross it. Why do we need the wide streets? Is it just traditional? We feel comfortable. Can we reduce the street width? And what do we gain? You know, well, what's the problem with street width? Why would that help us if we reduce the street width? How would that help us? Break up impervious and less impervious? Right. Yes, because we have impervious. Can the water go through the impervious? So we minimize that. The more area we can have for water to influence into the ground. Again, this integrated system where we can have streets, we can have rain gardens. We'll talk about rain gardens. We can have different systems on the sites, multi-use. So the purpose is to reduce impervious surface. The function is reduce this impervious surface. Okay, and we're still into the pollution prevention approach.
We can all ask our cities to adopt the Living Streets policy. So ask your city, do they have a Living Streets policy? Maplewood has one. Edina is working on one right now. All of our cities can adopt this so that their new streets, when they're reconstructed, will look like that.
Absolutely. Exactly. Not everything can everybody do the same thing, but we can be open to the ideas. So if the city comes, or maybe we can contact the city, we can be open to the idea. We say, oh, this may work. This may do a number of things for us. Okay. Someone did already mention this connect surface area. One of the things we learned to do is when we design something, we engineer a structure, we want water from point A to point B as quickly as possible. Well, when we looked at the natural drainage system, we had lots of puddles and low spots. That's not how it works in nature. We like interruption. You know, we want the water, so we want the water we don't really want the water from the roof directly into the outlet down here. We want the water from the roof to come down here, go over the grass, sit on the grass for a little bit, find its way downstream in this little gentle slope before it really goes to the outlet. So rather than having gutter to the storm catch basin here, what we want to have some interruption between, so it can hit the ground, so water can infiltrate into the ground, maybe, or just slow it down. So maybe we have a street that doesn't have a curb. Maybe our city would be open to the idea of having, if it works. Nothing ever works everywhere, but if it works, maybe we can have a city without a curb. When the water comes, so we have designed it properly, so the water comes down here, slows down, it goes into the ditch. We've designed it with the check dams. It takes a long time for the water to get downstream. Gives it time to infiltrate into the ground or evaporate, so we reduce the water. Again, the gutter, rather than having a gutter to go on our driveway, maybe we can just turn it 45 degrees and put it in our garden. That would minimize a great deal. So all these things would work. These are all, again, non-structural BMPs. These are just adopting different practices. What about stormwater use? We have all this water during the summer. We spend money to get rid of the stormwater, and then we go and turn on the tap. We spend money to water our grass. Somehow this equation just doesn't seem right. So it's a very simple process. Why don't we harvest our stormwater during the summer, not spend the money and the water from the aquifers that we're concerned with, and use the stormwater for our outdoor use? Because if you look at total use of fresh water, about 15% is for the households, and out of that, more than half of it is for the outdoors. So we can be very effective by simply using doing the rain harvest and reusing the stormwater. Okay, that was a very quick overview of pollution prevention BMPs. So what do we do? What do we do here? So we try to minimize the rainwater runoff as much as we could, right? The area is thicker, but now we're going to narrow it down. We did everything we could, but we still have some runoff on our site. Now, the next step is to do what? Source control. Is there a way that I can hold that water where it falls? I want to hold it right there. Well, what choices do I have? If the rain hits my ground, one of the easiest things is, if it's feasible, not always is possible, but if it's possible, can I encourage it to infiltrate into the ground? And that way, not only I minimize it from going downstream, I did pollution prevention, but I'm also reducing the volume. I'm also minimizing what goes down. So now we're going to focus on source control. And I got my disclaimer here. Again, not everything falls in every step. So some of them may go here, a little bit here, a little bit there. So you're okay with that, right? All right. Okay. If my goal is to infiltrate the water into the ground, what's my number one ingredient? Right? That's what I got to work with. We've got to remember, if I'm gonna use soil, I better have the right soils in the ground. If I don't have the right soils, nothing works. You may find it interesting, but it's a reality. You work with a lot of people who design lots of things, and you have to have troubles. They come to you, they say, this is not working, this is not working. We ask the question, have you tested the soils? It should be the first thing. Our main ingredient is the soils. We've got to have the right soils, generally. Okay, generally, a good soil is about 50% solids, quarter of it air, and quarter of it of water. So that mixture makes it feel like a sponge. That's sort of a soil we want. A soil that has lots of porous area where the water can find itself into the ground. So we deal with the sponge, right? And that's where we can have aquifers, because if the sponge, it can hold the water, and we can tap into it, suck up that water, and use it for whatever else we need. But what happens if you have a sponge and you press on it? You compact it and you press on it. It's going to turn into a brick. If you press the sponge, can it absorb water? That is exactly what we do when we compact the soil. They've done tons of research, and we've known this for decades. So if you look at both sandy and clay soil, it doesn't work, so universally works. But let's look at just the normal soil. If this is our native soil, the soil that has not been compacted, if we pour water, it tells me if I pour up to 10 or 12 inches of water per hour, that water can constantly find its way through all the small pores in the soil and infiltrate into the ground without me ever seeing a runoff. That's pretty good, right? That's what we want. But what happens if I start parking my truck on that soil when I'm doing construction? If the ground is not level, I say I want it to be pretty nice level. I bring a compactor, make it level and everything. Look at what happens when I have to compact it. When I turn that soil into a brick, what happens to my infiltration rate? Almost non-existent. So the first thing when we're dealing with infiltration, what's our ingredients? Soils. And we have to have a healthy soil. Do we want the soils to be compacted? It's your enemy. You won't believe how many problems can be eliminated if the first thing we did to check to see if the soil is compacted or not. But if it is compacted, we can remedy it something. Yes, ma'am?
I have a very practical problem. You're supposed to wash your vehicles on your lawn.
Yes.
So that you don't have runoff, but then that compacts the lawn. I mean, where's the...
Very good point.
Which way do you go?
What do you think? Yeah, what do you think?
Well,
I'm with them.
We have sand, and we come back with a lot of soil from
Yep.
up north, the truck is washed on the lawn where there's sand, so I think we get pretty good infiltration, but it really is killing the grass.
Especially if you do it always on the same spot.
Yeah.
Or maybe you can do it on the driveway, but find a way to grab the water from the driveway. And we do have a best management practices. We'll show it to you, and that might solve some of the problem, because that is a real problem in many places. For example, the cities have utilities where they have to have access to a water main or electric that's buried into the ground, and if they can't, but they have to have access to it. You got to have an access road. But if it's grass and you have these trucks going on it, exactly that happens. But there is a solution for it, and we'll keep you suspended. So we'll see the solution. Oh, it's the next slide. So basically what we're trying to do, okay, we're saying we have soils. We want to make sure our soil is good. If we've got some issues, there's some techniques we can do to bring some of the functions back to the soil. But the best thing is not to screw up the native soil. Don't make once we compact the soils, it's a very hard battle to get all the functionality back. But there are ways we can do it. We can what they call soil ripping. We can cut the soils to basically try to fluff it up, or add organic composting. Does a fantastic job. However, what's compost? Exactly. And what is it? Nitrogen. So it's a battle of trying to balance it. I'm doing all these things to eliminate nutrients going downstream. Composting is introducing the nutrient into the. So it gets. So we got to be careful how we go about these things.
Doesn't tilling destroy the natural good qualities of soil? Like it kills I can't think of the term, but yeah, exactly.
Sure.
Oh, I'm
Right.
sorry.
You're correct. This again, what we're trying to do, we're trying for our specific task, we're trying to promote infiltration. One of the ways to promote infiltration is to correct the soils or to restore the soil's function. If it's compacted, is to do tillage to basically fluff it up. But you are right. There are, as I said, there's a balance, because this is composting does magic, but you got to be conscious. Where does my water go downstream? If it's going to somewhere sensitive, you probably don't want to add nutrients. So you got to ask that question: where does my water goes after it leaves my site? Okay, so here we have example of where we are turning. We have to have a hard surface, but we can construct a hard surface in a way that the water can infiltrate into the ground, and this is going to help us minimize the runoff, because now I can pour the water, it goes into the ground, no problem. This is one of the examples of having where you can have grass, but also have areas where the car can drive, and you can wash your car and do other things, but you're interrupted. You have disconnect surface, so the water goes through the grass before it goes downstream. Or you can park your car on the grass. I'll get to that in a little bit, and we'll show you how to create that grass. So here is the pervious pavers. Basically, how do I construct pavers that have the underlayment so they can, when I pour the water, it can infiltrate and can go into the ground, but it can hold the weight of a car as well. What am I looking at here? I'm sorry? Pervious. Does it look perfect?
No.
What do you see then? Things are growing. They got things all over it, right? And what do you think is happening here? Maintenance. Exactly. I never paid this gentleman. That was a perfect giveaway. Because you got to remember, we're doing all these things. The system that's carrying lots of debris with it and everything, and they're acting as a filter, right? They're capturing everything else and the water going infiltrating into the ground. So if they are doing their job, we're going to capture stuff on top of them. So we have to clean these things. We have to maintain them. And this is what's going on here. They're washing the system. And it's really important to remember, maintenance, it's not end of the project. It's not the beginning of the project. It's got to be through the whole project. Even when you're doing as a homeowner, if you're doing a rain garden, anything you're doing, you got to remind yourself, if it does its job, you're going to end up with something, right? It's just like having a filter in your furnace, and the filter is absolutely clean after 2 years of use. Well, something is not working, because if it was working, it should have captured something. It's the same idea. So the maintenance is to restore the design function. Maintenance always has to be part of it. We don't have time to jump into maintenance, but just, I don't want. Yes, ma'am?
Is that supposed to say restoring or resorting?
Oh my gosh. Terrible. I'm sorry. Restoring. I'm sorry. To restore. Good catch. I wish I could tell you I would be spelling free, but okay. But thank you for noticing that. To restore the design function, and remember that it has to be a design, right? We don't do this without planning. Okay, so let's go back to that car that was parked on the grass. We have a lot of what we call this artificial turf, or basically all this is a plastic that gives the soil that fluffy, keeps it as a sponge, but also gives it a strength so we can have a light truck or a car to park on the grass. So we can have our grass and can withstand that compaction so it doesn't kill the grass. I know these things are becoming more and more available, and it's not as expensive anymore. I use this. I've never been to the site. I use this example. I hope it's okay with the folks that I borrowed the material from. I just thought it was the greatest example. They had this beautiful park from the story that I read. They had this beautiful park, but I really identified with the problem they had. The ordinance changed, and they said, you got to have a parking here. You can't just have an open area with a parking. You got to have a space for parking. So the dilemma was, okay, I have these beautiful trees, I have green, I need parking. What do I do? Do I go out there and cut the grass, cut the trees and put asphalt to put the parking so people can enjoy what it used to be there? So their thought was, well, why don't we take this area that they had was already gravel. They put some of this material, this mesh or the turf builder into the ground. They backfilled it with gravel, and they kept. So what this allows is the idea is pervious pavement. So they're keeping the area open to infiltration, so water can still infiltrate into the ground. They did not have to capture the runoff, because if they had made it into asphalt, they would have to capture the runoff. Now they have to deal with it, so they would have had to cut down trees in order to treat this runoff. This way, they don't have to have runoff at all. Everything goes infiltrates into the ground. They had the opportunity. So it worked for them perfectly. They solved the problem. They still have everything. They got their parking. So it's a good example. And this can happen at the home scale as well. Again, rainwater harvesting, we talked about as a pollution prevention, but it's also controlling it. If I've done everything, I still got runoff, why not hold it if you have the opportunity? Many parts of the world, they use this as just a normal function. I used to live in Worthington, Minnesota, and we had an old house, and the first time I got introduced to the idea was when I went in the basement and someone had to explain what a cistern was. And so many homes used to have cistern holding the water for later use. And that, so that's also site control. Okay, let's talk about rain gardens for a little bit. What about rain gardens? They're wonderful. They're a good example of how we can create a BMP where we can promote infiltration into the ground so we can lose water into the ground, but also we have plants. And remember our natural landscape versus the impacted landscape? What helped the water evaporate? The plants. We got all the plants that are fanning the water, so there's more water we can lose through the plants, right? So we lose water both through evaporation and through infiltration. So that's why rain gardens are so effective. For tonight, we're going to lump them all together, combined retention, infiltration, and filtrations. And I know you have other nights you'll talk about them, and you'll distinguish the difference between all those as well. Of course, bioretentions, they're beautiful to look at. Why is this picture interesting? When I took this picture, it was gently raining, and I think I wrote it down somewhere, but it had rained like half an inch already. But if you look at the ground, what do you see? No runoff. Everything is going to the ground. Not only everything there, but all the water that's captured from the street, it's also going infiltrating the ground. So they work. I'm sorry? That's in St. Paul. It is actually, it's a ravine that they took the whole ravine that was, attracted garbage, tires, everything else. They turned the whole ravine into a rain garden area. And this is same connection, same system. This is another example of the rain garden. Basically, what they're doing here, what I want to show here is that open curb here. So on the streets, you can have a rain garden on the right of way between you and between your property and the street. So as a homeowner, you could be open to the idea. So in the poor person, as a person who's done it, you go knock at the door, and you don't know who's going to open that door, and then you're going to tell them, hey, can I have some of your property so I can put a rain garden? Be nice to that person. That's what they're talking about. So on the right-of-way area between your house and the street, they can put the rain gardens. We'll talk about what it does. But there you open some of the curb so the water can get into the rain garden. Okay, so again, so the idea of what's the purpose of the rain garden? To reduce runoff. It reduces volume. That's really important because it's treating it on site. And the function is basically, it's anywhere we want it to be above the water table, right? Because if my rain garden is below water table, is it going to be able to absorb water? No, it's already full of the groundwater, so it has to sit above the water table. So I want my rain garden to be above the water table, and that is a low ground, low spot where I can capture some water temporarily, hold it, allow it to infiltrate the ground, and somewhere to evaporate. That's my BMP, yes?
I just have a question about soil aeration, because I've been told by people that the plants will aerate the soil too. I mean, do you consider that, or is that bad information? Because the root systems and the depth of them.
Absolutely, absolutely. One thing we're learning is that, or plant people knew that, I'm sure, for decades, is that every season, plants shed about 1/3 of their mass as roots. So what does that mean? So they make all the roots in the soil. They're going to die off, leave it there, and create new ones. And that one is going to decompose. It's going to be gone. You're going to end up with all these pores, all these channels, all the areas that the critters and the water can get into it. So basically, it changes the soil into a filter. And actually, at the beginning, when we started to do this in Minnesota a couple of decades ago, everybody was worried, well, this thing is going to plug up. Yes, it does plug up because you're constantly bringing debris in here. It's going to go in here, plug it up. At the same time, those roots are increasing infiltration too. So it works both ways. Okay, so I'm looking at the rain garden. I had to put this here. This picture didn't come out right. It's actually downhill, but the water flows downhill, right? So we always have to have the angle work with us. And that's really important because when we started building this at the beginning, we weren't thinking about that. We were making the same level. But now we're learning when you have this curb open, the water has to fall into your rain garden. So you have a rain garden at home, you always got to think about it. Is my water going to fall into my rain garden? Because it can't go uphill, right? Always got to go downhill. That's and actually this is a more common problem that you would think. Okay, I know we're short on time, but give me can you name two features if I showed you this rain gardens? Can you name me two design features on here? Two things that you see. One of them is really easy. Storage, exactly. Storage water. It's got to be able to hold some water. That water that's coming up from the watershed, from the streets or from your parking or from the roofs. Hold that water for a little bit, at least 2 days, to allow that water to infiltrate into the ground. And later you actually will design one, I know, in a couple of sessions. So the storage, and what else do you see here? Plants. Yeah, bio retention. So those are some of the features of the rain garden. So we can store water, we use plants to promote infiltration and evaporation of that water. And they come in every shape. You can have them the size of in the backyard. This is the blue thumb. How many people here work with blue thumb? Blue thumb. Oh, gotta look it up. Google it tonight. It's really, it minimizes so much work. It's amazing. I mean, years ago you had to go search for the plants. Today you go on this website and say, I want it blue, I want it bloom in such a week, and so forth. Boom, the list is right there. No need for botany.
One of the things that you'll get as we get to the part where we're designing rain gardens is we'll give you one of the blue fungi.
Yes. Very, very good site. We're very lucky. There's a different ways of showing you how they do. You can capture the water from the, this is a large parking lot for a home. It could, basically the same principle will work from home. You capture the water. You try to capture all the large sediment first, pre-treatment, before it goes into the rain garden. These are basically pre-treatment area. That's a very good name. And I actually have more picture of it because there are a couple of tricks into how to do this, and some people have used it. I'll show you a couple of pictures later on. Trees, again, it's funny how we're going basic. You know, finding out trees actually are beneficial. You know, I know it's a very radical idea, but now we're thinking, well, we can use trees for more than just planting them. If we plant properly, if we know where to plant the trees, and we understand the trees need oxygen just like plants. We can't have compacted soil. We can't put trees in the middle of a boulevard, asphalt all over it, and then wondering after 2 years, why is it, or 5 years, why are the trees dead? You know, so, but if we can do the trees, plant them properly, this is happening in the city of Minneapolis, we can provide the structure where we can hold the weight of the sidewalk or the cars or the asphalt, but doesn't compress it, still provides oxygen for the roots. The trees provide fantastic. They do a number of different ways. Yeah.
I don't get what the form and, oh, I'm sorry.
Okay.
What is the black? I don't get what.
Oh, I'm sorry. These are just the mesh. There's this plastic mesh that you install and you backfill it with dirt. So when I put my pavement on the top, that weight is coming on this plastic and not the soils, and preventing the soils from being compacted. I'm sorry. Yeah.
The interesting thing you said about properly planted trees is that after the June storm, they used to plant trees on boulevards with huge root systems that couldn't penetrate the ground. After the June storm, that's why there was all that damage.
Yeah.
The storm we had in June 20.
Got blown down.
Also, in replacing sidewalks, they were chopping the trees.
Yeah.
Another question though is most of the boulevards in Minneapolis are extremely compacted, and that's where the boulevard trees are located. So what could a water steward do to help and get these rock solid boulevard grass that's like cement?
Yeah.
Would you just like aerate it, like put in a little, take out an aerator machine to like take out plugs of dirt, or how do you this little area between the sidewalk and the street is like.
So urban soils, compaction is the biggest problem you will confront. Every single residential lot has compacted soil, period. The boulevards are compacted, your front yard is compacted, your backyard is compacted. It is the biggest problem with urban soils. So a boulevard, well, first of all, it's not your property. It belongs to the city, so there's a limited number of things you can do with a boulevard. You'd be better off trying to put a rain garden in a boulevard because the process of building a rain garden will fluff that soil some. But there's very limited amount you can do with boulevard trees.
Since the city owns the property, do you have to get permission to put a rain garden on it?
Yes.
The right of way?
Yeah.
Okay.
The question asking is people.
So my question is about putting impervious pavers,
Yes.
but like in a sort of residential area, because both of the examples you gave are sort of large industrial where they're putting in this product. But like if you're just putting in regular, garden path or something, you would be tamping to make your pavers level. So you would be compacting as part of the process.
Correct.
So I mean, it's sort of.
You would, and you actually do the same when you're doing the pavers. I mean, Minnetonka Community Center, actually, there's a good example. They have a portion of the parking lot that they have used as pavers, and they have porous asphalt there as well. So they have to compact it. The trick is the underlayment, you use the right size rocks, and you use the right material so you can get the impacted, but they still are porous, so you still provide the storage. So they have basically those rocks do exactly what these plastics are doing. They give you the strength to hold the weight, but they prevent compaction, so you still have those pores within the soil so you can hold the water in it. Did I answer your question?
Yeah, you did. Thank you.
Okay. And then maybe one more question, and then we'll.
Okay, quick. So I have a really long driveway, and it would cost a fortune to put in the pavers. Does it do any good to put them in the last 10 feet, or can I make troughs? Or, all my neighbors
You
have
beat
the
me
same-
to it. Home Depot sells them. Yes, I'm saying go.
Actually, we used turf stone.
A what?
Turf stone.
Oh.
Yeah, he did 2 strips of turf stone, kind of like the one picture where you had they have the grass between, and then the turf stone you actually can plant in the holes.
We'll look at some of
Okay.
those designs.
So they solve the problem. Yeah, but the trough, and actually those plastic troughs you were talking about, the Home Depot actually sells it. So you can so if this is driveway, at the end of the driveway, you can make a cut and put them in here and direct the water to, well, you got to have a place for the water to go. So, and that solution.
And one of the slides you had those strips with
Yeah.
grass between, and those work great.
Okay, so trees, green roof, I just used an example. I know we're not, but I see some people have used it even at home level. Green wall, when I took these pictures years ago, it was such an exotic thing. I felt it was so cool. I was the only one who had a picture like this to show green wall, using a wall as a system where you can capture water, you can hold water, you can store water, minimize that water moving downstream, slowing it down. Just Google green wall today. It's a whole industry.
I think it's Barcelona is all green walls.
Is it? Yeah, so it's a whole new industry. I mean, it's just thriving, and just all architects are using all over. Infiltration. This is another source control. So I've done everything, but I can't do a rain garden. I don't do anything, and not only that, I only have 1,000 square feet, or well, this is more than that, but let's say, and I need that area, my flat area, I need it for parking lot. So what do? Well, maybe I can store the water underneath parking lot. Maybe I can put these pipes where I can store the water temporarily and then promoting it, allowing the water to infiltrate. And on top of that, I can put a parking lot on top, so I can use the whole area. So that's another example. So this is what we. So this was the source control. So now we minimize as much as we could. Now we have to allow some runoff to go downstream. Here now I have to treat that water before it can go downstream. And one thing I want to say, everything we've talked about so far, we actually did treat the water too, right? Because by minimizing it, by reducing it, you don't have to do anything downstream. I don't have to deal with the dirty water downstream. I don't have to spend money cleaning that water. So all the prevention, all the source control is also a treatment BMP as well. Water quality, when we talked about it, what are these ponds? In the new developments since 1980s, you see them all. Basically, the law says you can't let your water go downstream if it's not as good as when it came on your site. So in order to do that, I dig up this hole or a pond. I hold the water. The water comes with all the sediment, all the nasty stuff in it. I hold the water, allow those sediments to settle to the bottom, and then I let the water go at a specific rate so I can control how fast the water goes downstream, and it is also cleaner than when it came into the site. Of course, what do I do after 10 years? I have to dredge. I have to clean that, right? And what I do with it is a whole different discussion. We'll have a whole class on that one. So, sorry about that. So, what can I do as a homeowner about the water quality fund? Be aware of what they are and be picky of what you accept. Is this this is a nice look of a pond. Yeah, I would love to have a house that would have us next to this one, but I probably end up with a house that has something like this next to it. I look at this pond, what do I see? I see this sharp slope. then I see an 8-footer wall, then I see a 6-footer fence. Well, first of all, I'll never get to see that. I mean, I have to go through a length to get this picture. I don't get to see this pond. Then, if I ever fall in here, what's the likelihood of me ever making it out of this place? I mean, this is not, and it's not doing any good. So I can, as a homeowner, I can communicate with the city or whatever it is to say, well, I can turn this pond. This is the Hennepin County Library in the city of Plymouth. I mean, it's the same scenario. They still have to use retaining wall, but guess what? This is a city park next door, and people are right there, and people walk by it all the time, and they enjoy it. And most of all, it also brings back some of the function of the ecosystem, because you have flowers. I heard talking about bees and insects and everything else. So again, as a homeowner, yes, I cannot go out there and construct a water quality pond, but I can know about it and I can request one that's functional. But I do inherit a lot of the problems with the water quality ponds. If you have them, I didn't see that many hands, but usually the problems you have is that you got to remember, we constructed these ponds to trap trash. That's what they're for. So if you see trash in it, it's because they're doing their job. Not everybody is open to that. If you spend lots of money, buy your house next to a water quality pond, you expect it to be in the condition that a salesperson told you that it'll be there forever. But that doesn't work. If it's doing all these things, that means it's doing its job, right? It's a good filter. It's trapping everything. But the issue is that we have algae, we have trash, plants, and so forth. These are some of the issues. And of course, we have the algae is the biggest problem, or the duckweed on these ponds. Again, they trap in the nutrient, and you have the sunlight, you have the water. Of course, the plants are going to grow. So they're very productive. And they can be maintained and cleaned on a regular basis. And sometimes we go into larger ponds, and they treat a whole neighborhood, and they're called the regional ponds. And again, as a homeowner, we don't do that often, but just you may enjoy seeing some of these. Okay, I know we're short on time, but let's take just a couple of minutes. Let's do this. By the person next to you, let's talk about a couple of this being. I know we just ran through lots of tools, and if you're sitting in this shop and say, what the heck was in the toolbox? Let's take a few minutes and look at can you identify maybe 2 or 3 types of these tools or stormwater BMPs we talked about, and maybe just among yourselves talk about what is their function, what do you think they do, and how do you think they would work. Hey, talk about how would you go about selecting them. Let's take 2 minutes. Would that be okay? Yeah. All right. Per hour in 20 minutes. Okay. Okay. This table, would you guys like to share with us what you have found? What was your discovery? I'm sorry, I don't mean to put you on the spot, but now that if you like to share, now that you're on the spot. Yes.
Well, we were talking about disconnecting the impermeable surfaces and ways to do that. I thought that was really
Very, very effective. And what does it do? When we disconnect, let's say I own this huge house and it has a huge roof, and the gutter collects all the water and it goes straight to my driveway, straight to the catch basin. But now I want to introduce disconnect as a BMP. What would I do?
We were talking about the idea of long driveways and putting in the trench thing to
Exactly.
water off to the side.
And trap the rain roof water with that also, and take it and put it into the garden. What does it do? It minimizes that water going downstream. You reduce the volume. You don't have to deal with that water downstream. You reduce the pollutant load downstream.
Because asphalt is a pollutant too from the roof.
Absolutely. Everything gets captured on it. Okay.
Asphalt is a pollutant.
Good. We're going to zip through this. I'm sorry. I apologize. I tried to keep the best for last, but I always run the danger of not having time to covering it, which is preserving natural areas. The best thing we can do is not lose that natural resource that we already have. And this is really important. As a homeowner, again, I may not be able to do this, but I do have a choice. I got to remember, the whole marketing works because I make a choice as a consumer. And if I change my choice as a consumer, and the market will reflect eventually. Maybe not right away, but it will. It always does. So I can make a choice of what I do. And one of the things we can do, we can demand, why destroy what's already there? Preserve the natural resources. It's very easy. So how do you do it? This is a quick example of a high school that was a couple of decades ago in the city of Plymouth. This is the area. This is an aerial photo from 1956. And the idea was, I want to make a high school that's large enough for 4,000 students. How do I? This is the property I had. How do I do it without destroying everything, but keeping some of that natural hydrology? Yes. Ah, see, were you happy with it? Oh God! No, it's some other city. So we'll talk. So this is the area. So this is the area we have. So we want to see how we got there. So the first thing you do, you go to the site, you do inventory. Let's go through it. What do I have on site? Do I have trees? Do I have springs? Do I have creeks? What do I have on site? Evaluate. Can I keep everything? Are some things that maybe, they got to go, but can I at least keep track of what functions I'm removing? So that way I know. And then I can design accordingly. I can design to use of the function that exists and to replace the functions that I've lost. So what did they do here? So they started with the site. The first thing they did is, okay, let's do an inventory. We have trees, and it seems that we have a nice creek here. We don't want to mess with the creek. We want to keep the creek. So we have the trees, we have the creek, and the arrow shows this degree of the slope and which way the water flows. Because I want to keep the natural hydrology. I better know how the water flows on site. So I keep all that information. So then I did not do this. This is the company, the architect company. They started saying, okay, now we can design the building rather than redo the landscape to fit the building. We're going to change the building to fit the landscape. That's the new concept. And then we're going to introduce lots of green areas. So it's disconnected surface. No water goes from here to here straight. It has to go through a number of different steps before it makes its way through there. So at the end, when they built it, it fits into the building, into the site. And it works very nice. Lots of natural area, lots of green area. The parking lot, it's all open. And when you look back 10, 20 years later, and things are still functioning, the trees are still there. The constructed water quality pond to capture all the water, extra water, all the water that we couldn't infiltrate in the ground. They captured it here. It looks part of the system. It goes to a constructed wetland. The water flows from the parking lot to here, from here to a constructed wetland before it goes into the creek. Guess what? By the time that water gets down there, it's pretty darn clean. So it fit into the system. Okay, I cannot build a high school, but certainly I live in a city that may build a high school. Certainly I have a system that I can participate in that decision making. So what's the features of preserving natural resources? Well, first of all, it reduces impervious cover. If I don't have to pave on it, if I reduce pavement, it's an improvement. I can use the pervious area for more than one thing. Not only it's a green space, it can be used for stormwater. And remember, the goal is always to reduce runoff. And preserving the natural area, I think it's one of the most effective ways. I mean, and we have to learn to start fitting development into the landscape, into what we have, and not always change the landscape for the development. So we're going to design like nature. This is a review for you. So just remembering, as we talk about, So where would if I were to put the BMPs on the slides, where would it go? Where would the BMPs go? When I talk about tools, I'm talking about green space, I'm talking about rain gardens. These are my tools, right? And these are the tools that help me to bring back some of the function of the natural landscape. And we have lots of tools, lots of different things that we can use. Main message, we have what to do the job? We have tools, we have solutions. We have solutions. It's not easy, but we have the ways to do it, to correct the process, to do it. So very quick review of what we have talked so far. Why do we care? Thank you. For a moment, I got worried. I said, no one said, why do we care?
Finite amount of water.
Finite amount of water. And we want clean water. Who is against clean water, you know? So we care because we want clean water. What is the problem? 3 problems. I'm sorry?
If the land is, the property is developed.
And that creates excessive runoff that creates 3 main problems for us. You can't leave tonight unless you know those 3 problems. Right. Why is that so important for me to know it? Because if I want to implement a solution on my home site, it has to do one of those 3 things, right? It has to address one of those 3 problems. Okay, so we have too much water that moves too fast and it degrades water quality. To solve the problem, I solve my problem through what approach? Mimic natural hydrology. All right. Wait a minute, I can read this, you guys. Come on. Okay. So, but mimicking natural hydrology alone doesn't do it, right? I got to consider 2 things before I can do that. I got to be mindful of what? Yeah, we got to ask the question, where is that water coming from? And most important, where does it go after it leaves my site? That's really important. And can I plan my next 30 years to be exactly the same as the past 30 years? What I thought the plant, this is from true experience, a few decades ago, when I used to work with landscape contractors, they would guarantee the trees for you. I planted, it's guaranteed for the season or 2. It doesn't work that way. Part of the guarantee is I need to water that tree. With a pattern that I could rely on it, every time I got water, I got rain at a certain month, it's not for sure. It may not happen. Things change. We got to change our plans according to what is happening in the future and what may happen in the future. So we got to design with knowing the change. We have a climate change to deal with, and also we need to think about watershed. And the way we categorize our best management practices. Remember that chart that I showed you with arrow? That is a treatment train, right? We focus on the function of the BMPs. Okay. Oh, sorry. I don't know why this does. All right. So believe it or not, I think we're almost getting close to chapter 4. Okay, so because chapter 3, we talked about solutions. We introduced lots of solutions. And now the idea that we're going to focus on the function of the BMPs. We're always more interested in the function. Sometimes it's easy to get caught up in the technology and how nifty they are, but we always want to ask the question, does it solve the problem? Does it address the issue? And we have to remember, there's no one BMP can do everything. If I'm a mechanic, do I deal with only one tool in my workshop? No. In my shop, I have everything. I got to have lots of tools. It's going to require lots of tools to solve the problems. There are no silver bullets. I love this saying. It says, if you've heard it before, if all you have is a hammer, everything looks like a nail. And that's exactly the same thing with stormwater too. If you thought rain garden was the only thing that could solve the problem, well, that's not really realistic. It's always going to require a number of BMPs, a number of solutions to solve the problem. Okay. So that was our review. Again, what are we looking at here? I'm sorry. Is it bother you that I keep asking the question? Yeah, hydrograph. And okay, if I point to this, what landscape am I pointing to? Natural. And this one pointing to what? Okay, and this is global water. Everything we talked about was about minimizing, mimicking natural hydrology. That's what we're talking about. And this is what causes the 3 problems. We won't tell you, right? And you know the treatment. Okay, may I ask a quick question? I know we have a few minutes. We can do an exercise, or I can go through some of the pictures of BMPs. What would you like to do? Would you like to see the pictures of BMPs? Okay. Stop me from, but I didn't tell you. This is worse the other way around. I showed the picture. You tell me what we're looking at. So feel free to tell me, what are we looking at? Rain garden, somebody said rain garden. Yes, it's a very sandy rain garden. It's a very sandy rain garden. The person who designed it knows the plants that will last there and be functional. It's early in the season, so it doesn't look totally there, but it was early in the season. It is functioning. So it's a It's a BMP. Where would you put this BMP? Would it say is it pollution prevention, source reduction, or treatment? Treatment and source reduction. You're right. Yeah. Good. All right. Ready? What are we looking at here? Exactly. Stormwater pond. Don't you love the idea? They did this. Why not make it aesthetic? Why not bring arts to it? You know? I mean, there's no reason they cannot look nice. So they have this waterfall. I mean, I was sitting there, and the sound of it, it is cheating. They actually have a pump. They run the water through it. But why not? I mean, okay. This came up, what we decided to call this? Trough? Pre-treatment before the rain garden. Somebody thought, well, why don't I make it the same size as the shovel? So when I go to maintain it, I just put the shovel and walk, and boom, it's done. It works. It requires the maintenance, but they put it before the rain garden, and they have, this one is a smaller, like a homeowner size, home site size, and it captures all the treatment. We used to be in love with rocks. We're learning rocks gets a little complicated to clean rocks for pre-treatment. It's not as easy. What are we looking at here? Exactly. What is it doing? Slowing the water. My gosh. They are great. All right. What's happening here? Reseeding. Hydroseeding. So what do? Well, I've learned if I mix the seed with a bunch of stuff that can keep it on the ground, also provides the nutrient for it, it will keep the moisture in the ground, and the seeds will grow. So germination rates increases tremendously, and the survival rate increases tremendously. So all of a sudden, I have this bare ground. I have a choice, letting it be bare, and the rain comes, washes everything out, or I can do a hydroseed to protect it and allow the vegetation to grow much faster. What are these two PhD people, by the way? What are they doing? Actually, let me give you a quick couple background. So I'm standing here, I'm maybe about 50 feet away from them. I'm on the edge of the water quality pond. So they are inside a water quality pond. What's the first question you ask? I'm telling you, they're 40, 50 feet inside the water quality pond. They're standing in the middle of the water quality pond, but how high is the water? What are they standing on? They're standing on the sediment. So what they're doing, they're testing, they're figuring out how much sediment it's in the water, so how much sediment we have to remove. And it gets a little complicated because depending on what you're loaded or what type of sediment you have to treat it accordingly and dispose it accordingly.
Are they required to wear life jackets in that situation?
I was required. I was reminded that I cannot have people in the water videotape without a life jacket. So, okay. So what were they doing here? Water quality, measuring it. Maintenance. Thank you. So what are we looking at here and here? What are we looking at here?
That's a swale.
That's a swale. It's a very effective BMP, right? As a homeowner, all I gotta do, I cut my grass anyways, but I just provide this little bit of an area. Nothing different than the rest of my lawn. But the water comes here, slows down. What happens when it slows down? Drops off all the junks in it. And it has a chance to infiltrate and then go downstream. Very effective. It requires nothing just to work to let the city to do this. What do I have here? Excellent. Yep. Is this working? Right. One thing we got to learn. One thing I think we need to change as perception is a lot of people look at rain gardens or this BMPs and they say, "Oh, it looks beautiful." I am glad it looks beautiful, but from my perspective, if it's functioning, it should look like this, right? It is a little difficulty with home. I know having something in front of your home. Yes, we can have rain gardens that look beautiful most of the time. At the same time, we are looking for something that's functioning.
That one looks like, the one on the right looks
Yeah. Oh, on the edges here?
Yeah, because the vegetation is moving away from there.
You can see the weeds moving in. Good point. Okay, what are we looking at here? This is a school here. Actually, see the Worthington. This is a school here. Playfield. Home at the Lake of Pasadena is back here. And the water used to come from the school, go on where they play soccer, and go straight here, hit the lake within like 20 feet. They didn't like that. The homeowner said, all that water, all that fertilizer from the grass is going straight to the lake. So what do they do here? They create a bit of a rain garden, infiltration, wetland. This is a big area, so they have room to do it. You homeowners did this, you would like a shot. What are we looking at here? The rain garden, the parking lot up there. It's a retrofit. Afterwards, they say, no, why do we have all this asphalt? They went back, cut the parking lot, turn it into a rain garden. I'm not going to ask what are we looking at. You can help me out. What's the purpose of the rocks here? Tree treatment. Slowing it down before it goes in there so it doesn't wash all the time. And what are we looking at here? What do? They say, no, the rocks are really hard to clean. As a homeowner, you can learn this. Rocks look nice, but they're hard to clean. What can I do? Oh, it's just grass. I can use grass as a pre-treatment before it goes into my rain garden. Easy to replace. Every 5 years, if you have to replace it, the rest of it just mow it down. Okay, what am I looking at here? Oh, I wasn't going to answer that question. What's the PNP here? Are we done?
No, your mic died, so I'm going to give you this one. Your microphone died.
I'm sorry. I see it's 9 o'clock. We can end right now or a couple minutes. So we're looking at disconnect. Exactly. There's a gutter. So the homeowner said here, why have the gutter straight go to the driveway? They put this rock formation here, so the water, if they have a slope, they don't have to worry about the short circuit into this sump pump in the basement. So the water comes out here, and so the disconnect. Okay. What are we looking at here?
Probably a rain garden.
Is it functioning? It hasn't rained for 3-4 days. We need help here. Yeah. Okay, and very good point. These are facilities. These are equipment. Each one is different, and you can. At the beginning, we used to say after 5 to 10 years, you have to go and replace all the soils because it's going to get plugged. Now we're learning the plants are doing a very good job in some rain gardens where the infiltration rate is actually increasing. So it really depends. I mean, if you maintain it, but eventually you may get to a point where you have to go in there, cookie cut it, take everything out, replace the soils, and start over, which is perfectly fine. We just, it's a facility. It's a treatment facility. Okay. And here, they're using a mat for pre-treatment because it's important. If I keep talking about pre-treatment, we haven't explained it. If you have a rain garden, you want to protect all the investment. You want to pre-treat it, capture the sediment before it goes into your rain garden. So that's why you have all these steps. And then you have this beautiful rain garden. It's the second St. Paul. And this is island that they had in the middle of the street. They turned that into a rain garden. Again, as homeowners, this is all volunteers, homeowner volunteers taking care of it and maintaining it.
And why doesn't Minneapolis let us do that?
Minneapolis does not let you do that?
They don't put in residential curb cuts or rain gardens as far as I can tell. There's one at our house. There's one there on the border of St. Louis.
Just a reminder that BMPs, that they are, and we use the green infrastructure, again, to restore natural hydrology. I apologize, I ran over time. Watershed approach, you know this already, right? The last question of the night, I think. We're gonna, so, wow, you guys joined that. That's why I feel comfortable skipping what we're gonna talk about because That way, we're just going to show you the watershed, what the watershed is. Just very quickly, I was just going to, this is the state of Minnesota. I was going to show you we're here tonight. This is the Minneapolis watershed. This is Minnetonka watershed. And this is where we are tonight. And we're just going to show it how it is interesting that we're only just a little bit from Minnehaha Creek and Lake Minnetonka. And the idea is that, I guess that one of the takeaways is that, yes, stormwater is a large-scale issue. But in reality, stormwater runoff is a watershed-scale problem that can be managed at small scale, where the rain falls just like your home. So when you do something at home, the whole idea I was trying to make here is that it's always very closer to your watershed than what you think. It's all connected. It's so it is a large scale problem, but it gets taken care of at the small scale, right at the home site. And this was going to be an assignment. I'm sorry we didn't get to do it. I'm sure you're totally disappointed. But the idea is you could do this at home. Go home and try to draw your home site and try to figure out and draw everything on do a map of your parcel, your property parcel, and show where water comes on your property and where it leaves your property.
That's a really good assignment to do. That's a really good thing to know about your property. Just to understand on a very small scale how the hydrology of your site works.
Yeah. And once you did that, you'll be amazed. You can guesstimate based on the size how much water you're going to get after an inch of water, right? 1 inch over 1 acre is 27,000 gallons. So you can figure, you can do the math. There are tons of websites that will help you do the math. I mean, there's actually no math in this one. This one's just drawing. So, and we're done. I don't know why I'm going through the slides. I'm not going to keep you here, but I guess for the next week, what the expectation for the next lesson is that I think that's what you. This is your assignment for the next month, isn't it? 2 weeks. I'm sorry, 2 weeks. Okay. So bring in a news article related to water policy and identify the policy issue in that article. And the policy issue, you're going to be blown away. It's very, very, very interesting field of the stormwater management, dealing with policy and issuing policy.
Yeah, if you ever want to start a bar fight, just stop. Shane, thank you so much.
Oh, thank you.
Thanks to all of you. I know we ran a little late tonight, but there's so much to know. So thank you all. We'll see you in 2 weeks.